Okay, but here's some of the topics we're going to be going over. Just to start it off, the way for each of you then in your individual MATLAB script, we're going to do sections today. So sections are when you do just 2 % signs. It's going to make an individual section of code that you can run independent of your other sections of code. So we're going to do it all in one script. A script is where you're going to keep all of your syntax, which is the words you're typing on your screen. Keep it all in one MATLAB script. Be sure that's saved somewhere you're going to have in the future. So keep all your notes in there today. You're going to be coding a bunch. So at the end of the day, you're going to have all these topics covered in individual little sections of your code. And you can go back and run those and do whatever you want from there. Later on, we're also going to work with doing multiple scripts when you're going back and forth, calling functions, going back to your main script. We'll get to that towards the end of this beginner section. So we're going to start off with command window basics, IDE, formatting it. If you want to go dark mode like I've got here. We're going to do variables, basic data types, get into linear algebra, because MATLAB is the matrix laboratory. So everything is going to be matrices in here. You can do it as individual arrays and things, and we'll cover that as well. We'll talk about indexing, which is one of the most important topics for working with your data. We'll try to do some examples along the way, how to get help in the language. MATLAB has a bunch of support built in. Best practices, for loops, while loops, your control flow type of stuff, if statements, conditional statements. That'll kind of round things off in how MATLAB fits into the larger coding realm. I don't know how much we're going to get through today. We'll see. But each of these have to be about 5 minutes. So we're going to go fast, and we're going to cover a lot. Okay? In the afternoon, we're going to talk about more advanced data types like structures, very useful for holding different types of data together. We can do then kind of a choose your own adventure. If we want to talk about image processing, we can do that. If we want to talk about doing more advanced types of plots, we'll get into that. Integrals and derivatives. I've got a fun little tank animated game that I made in MATLAB. We can look at that and discuss like how those things come together and how to think of inputs and outputs very blockular to build more advanced programs like that. So the afternoon will be kind of a DIY if you're interested in staying. Pizza comes at noon. Any questions before we get into it? Tomas?
The only way I got here was like by carpooling. So the guys now sitting in the library. Can you share my pizza?
Yes.
Yeah. Cool.
Yeah, I got 4 pizzas for us, so we're going to have plenty of pizza. He's more than welcome to come.
Yeah, perfect. Thanks.
Yeah. Okay, so first things first, we're going to talk about basics here, and then we're going to get through, we're going to have people come up to the screen, so Mike will call you up in just a second. But your basic command window, I'll move this chair out of the way for you guys. And basic IDE. So an IDE is going to be your integrated developing environment. And it's split up into a bunch of different parts here in MATLAB. You've got your top toolbar, and this is going to be where all of your save function is, your running your scripts, your debugger, any preferences you want to set are all going to be in this top toolbar. On the left side, you've got your current directory. That's where your files are currently saved. It's just like opening up a file explorer on your computer and looking around. You've got back buttons here, you've got open a new file here, right? That's going to show you all your workflow. The important part about your current directory is all the files you want to use should live together in the same folder. When you've got multiple scripts that you put together to calculate volume, to go and export something to a CSV, you're going to want to have all those scripts in the same place, all relating to one main script, and this is all going to be in one folder. Okay, so this is very important when you're trying to run a script in MATLAB. Make sure this is showing that script here. Okay. Then on the very far right side, this is going to be your workspace. Okay, this is where your variables that you're working with are going to be stored. It's a visual element, so you can click through here and see what variables you created and what's available. This is also great for debugging when you're having issues with, oh, why isn't this variable looking in the same way I want it to be? You can start to check your variables in that area. Right now on your screens, you might just have a command window. Does anyone just have a command window? Okay. Top left is going to be new. There should be a button in the toolbar up here. It's a big plus sign. You're going to click new and drop down to script. That'll open up a place that you can put a lot more content as opposed to the command window. So you have your scripts here, and then this is your command window. Your command window is where we're going to start today. Okay, so if everyone could click in the command window, you should get a little flashing cursor in there, and just do something super simple like 1 + 1. Tomas, question already.
Is script like the highest order of element I can produce here? Like,
we'll get to that. We'll get to that. So you should be able to get right in your command window and start doing basic math here, right? 1 plus 1, you want to do the square root of something. SQRT, square root of 9. You get 3 out, right? Notice when you do that, in your workspace, which I need to show you guys, to get to your default layout, by the way, you're going to go to the Home tab, Layout, and then do Default. And that'll bring back any of these workspace and IDE elements. You can also click and drag them. Just click the top part of it, hold it, and drag it and move it around. If you want to adjust this thing, you can get rid of stuff if you just want to look at your scripts. Right? Very flexible. You can always go back to your default. Preferences, by the way, top and center there in the Home tab. If you want to get dark mode or anything like that, go into Preferences. Show that really quick, just so you guys have that option. Preferences, and then I think colors, and you can see everything in here, how I've set it up. My text is white here, my background black, and I've done all this other customization. So if you want to do that, you have this option here in Preferences. Very good. So your command window, you can think of it as a one-off calculator. You put it in there, it runs that one command, and then it outputs something and it's done. Right? You'll notice the variable that it stores is ants, which is short for answer. Answer is going to be your first variable. And if you type ants in your command window now and hit enter, go ahead and do that, you should get out the answer of whatever you just entered in. Right? That's your first variable. Variables are how programming languages hold information. They're little containers with a name, and then those values get assigned to those names. All right? So if you went in your command window and did ants equals any number, now ants in your workspace just updated, and it shows you that ants is now 20, like I just did. Right? So we're changing the value that's assigned to that variable name. Questions on that?
Can you just repeat in which option under the preferences we can do the dark mode?
So preferences.
Yeah.
And then you should go to colors. Yeah, you're right here actually already.
Colors, and then?
If you get rid of, let's see, programming tools. Yeah, we'll cover this. So that should be the editor somewhere too. Editor, debugger, just click on display.
Ah, yeah, okay.
Yeah, there's a bunch of options. I'll have to do this later, but
Yeah, I'm just
yeah,
looking.
it's in preferences. There's a bunch of stuff in here. Okay, so this brings us to different types of data types. So data is like the information we're storing with MATLAB, but there's a bunch of different types of things. For example, your name is very different than that integer 20, right? So MATLAB and every single language will have different ways and different data types that you can utilize. There are a couple common ones that go across them all. MATLAB doesn't use them all, okay? It does that for ease and simplicity. It also makes MATLAB a little bit slower, but for the things that we're doing today, you're not going to notice any difference there whatsoever. So MATLAB likes to store numbers as doubles, okay? If we really want to get into this, doubles store, it uses 16 bytes of information or something like that. We don't care right now about that at all, okay? You can store integers in this, you can store decimals in this, fractions in this, huge numbers up to like 10 to the 100th something power. So it makes everything one data type, so you don't have to worry about it, okay? There's also going to be strings. Strings are going to be created differently than doubles. For doubles, we can just do x equals 7, right? Let's start doing this in our script now. So Mike, you want to come up to the board, or come up to the laptop here? We'll start a section in our code. So new section is 2 parentheses. Get rid of my side.
Are you going to share the code later with us?
Yeah, we'll share this code later. It'll be in my GitHub. Come on up, Mike. So 2, or percent signs, that's our parentheses. Percent signs there will get you a new section. Now when you want to run this, you can just do Control-Enter. Okay. You can also use the play button up in, if you go to Editor, the tab Editor at the top, and then hit Run. That'll also do it. That will run all your sections though. Okay?
Quick question.
Yes, Emily.
If I just want to like write a line of notes in like HTML, it's just like 2 slashes. What is it in MATLAB?
Comments in MATLAB are a single percent sign.
Thank you.
Yep. So add a bunch of comments. Especially when you're a new programmer, do not feel bad about doing comments on literally every single line. I kid you not, that's how I started. And then as you get better, you'll know what things mean. You can get rid of all the comments. You can do comments above your code lines or right after they end. You can do a % sign and then right afterwards, an inline comment like that. So this run button runs all sections. If you click the drop down, you then have the option to just, to the left, not in that run, all the way to the left, you can click run section right there. Yep, and that'll just run the section that your cursor's in. I like to start every section of my scripts, and sorry, we'll get back to data types in a second, with CLC, clear vars, and close all. These are some commands. CLC will clear whatever's in your command window. In fact, go to your command window right now and type CLC in there, and then hit enter. You'll notice it just got rid of everything, so it cleans it out for you. Typically, you're going to want your command window clean every time you run a script, so you don't get confused what answers came from what parts you ran, right? If you run two things back to back, your command window starts to get cluttered. So start with CLC, that clears your command window. Clear vars will get rid of everything in your workspace, okay? Go ahead and do clear vars in your command window, and you'll watch answer gets disappeared. Boom. Answer's gone. Now, what happens if you type ants in your command window? Want to see if it, yeah, nothing happens there, right? The value isn't there. We have nothing to do with it. Nothing happens. So CLC, clear vars, 1 second. Close all will then close all figures that you have open. For plotting, this is going to be what you want to have to make sure you get rid of everything, make new graphs the next time. If you want to keep things around, for example, if you want to keep your plots around, you don't have to include close all, so just get rid of them. If you need to keep them up for something, you need to make 20 plots, then don't use close all. But this is usually how I like, you clean everything out, and then when you run the script, you have a fresh, new bit of information in there. So at the start of every little section here, I'm going to have CLC, go ahead Mike, CLC, comma, clear vars, comma, close all. Now you can also do these on all separate lines, and it's going to have the exact same effect.
Do we have to put a semicolon behind?
For these ones, you do not. Okay? Because they have no output. They're simply doing things to your system. Right? CLC, it's not going to give you an answer because there is no answer to CLC. It just does something in the IDE. But if you want to string multiple commands together, you can do a comma and put them all on the same line. That comma just allows you to put multiple commands on the same line. And it keeps your code a bit cleaner, right? You're not going to want thousands of lines here. Shorten things up when you can. Tomas brought up the semicolon, which we'll see in a second here. So let's define x equals 7 right beneath this, x equals 7, and then run that, okay? Just run that section. Control Enter should do that for you. And make sure, great point. So the CLC has to be after the double % signs. So you want to have %%, and you can title this section, just call it Datatypes, because that's what we're doing in this section. And MATLAB does not run this code, it's just there for us. Okay, so it looks at this line, it sees 2% signs, doesn't care, moves on to CLC, clear vars, close all, wipes everything out, moves on to x equals 7, and what's your output? What happens when you run that? Okay, great. If you have this error that pops up, guys, it's not really an error, it's just confused where you're trying to be. Click Add to Path every time that comes up. That allows MATLAB to find where your file is that you're trying to run. This is what happens when your current directory isn't where your file is. Okay, so you know how I mentioned at the start doing your current directory on the side? If it's in a different place, you have to tell MATLAB where that place is. So you just always add to path in that case. All right, so now if we run this, our output is what?
7.
Exactly. X equals 7. It's just telling us what we gave it. That's a pretty annoying output to have, so put a semicolon after that, x equals 7, and then you can suppress that from going to your command window. So in MATLAB, you basically have semicolons at the end of every line, so when you run the code, you have no output. But the variable is still created, right? We're just changing what MATLAB's telling us, but in the back end, the same stuff is still happening. If you wanted to see what x was, you could just type it later on in your code. You could add x right there, and it would give you the value of x again. You can also use the display command, and then it just shoots out the value of x. This will be more valuable later when we actually get interesting answers. But for now, suppress all of your outputs. So those are doubles. This is how you create integers. This could be 7.2. This could be -I. It's imaginary numbers, right? Everything's valid here in MATLAB, okay? For strings, strings are words, okay? And it's very different than a character. Characters are individual characters like the letter T or a period or something like that. You define strings, let's just call it name equals Emily. Right? And you need to put double apostrophes, quotes around these, okay? And this is now stored as a single element string, okay? You can also do Emily space and Jake. It's still stored to one string element called name, okay? Equal sign is the assignment operator in MATLAB. It assigns a value of sorts to a specific variable name. So let's go ahead and run that. And now you've got two variables in your workspace, right? If you want to see, it doesn't show you the types though. In your command window, type who with an S after, whos, W-H-O-S, and run that. And we'll see now what these variables are. So we've got the name, we've got their size, bytes as I talked about before, how much data is being used to store them. The class is what I'm talking about here. The class is the data type. We've got string for name, and we've got double as X. Makes sense. Good to check if you've got variables that you're running someone else's script and you don't know what form these things are in, run whos, and you'll get that information out. Okay? We'll get into size in a little bit, because that will be important when we start doing matrices. Okay, characters are a little bit different. Characters, instead of two apostrophes on either end, you're just going to do one. So let's just do, I don't know, call it whatever you want. I'm just going to call it bunch letters. And that's going to equal single apostrophe, and then just type some characters in here. Like that. Whatever you want, right? Just, it's storing a character array, basically. So this has multiple characters in it, though, right? 4 characters are in this array. So if we run whos again, run the code with your bunch letters in there, and then run whos in your command window. There we go. In the size of bunch letters, you'll see this is a 1 by 4, right? Because there's 4 elements in that character array we made. Okay? Questions so far? Tomas?
Why does the string store so much more, like need so much more storage capacity? Like,
As in?
Just because like the
Why does it have so many
character
bytes?
means only, does the character only mean like
String has a lot of bytes. Interesting.
the alphabet, or?
So characters in general are just individual letters, like a period. These are each a character in and of itself. So when you put them together like this, there's 4 of them. A string is basically a string of text, and it's considered one unit, and it brings this all together into one item. And that's why it takes more bytes, as we see in this case. Name has 164, because it's storing a lot more than just 8 bytes needed to store this guy.
The characters are just like a bunch of.
Exactly, yeah. And you could, here's the thing, you could change this, if you just made these single right there, this is then going to be a character array instead of a string. Right? It all depends on how you define it with either the single or the double apostrophes on either side. Good there?
Yeah.
The song.
So I'm just looking at the bytes that I took from my string, and I'm comparing it to that.
Mm-hmm.
And those names are capital, like the first letters, and I did all mine lowercase, but mine has more bytes. Mine's like 166.
That's kind of cool.
Yeah, I just noticed that.
Yeah, so basically, so every little thing you have, and this relates to how text is stored on a more of a macro level in programming languages, right? And if you made this if you did Emily and Jake and River, what do you think? More or less bytes? I mean, more bytes. It's more information it's storing. So the type of letters, what you're getting at, Dasan, is going to affect how much data is being stored. Because maybe an E, capital E and a lowercase e, to MATLAB has to have some difference in there, right? There has to be some character to tell it, uppercase or lowercase. So, yeah, don't worry about too much of bytes for now. We never have to really worry about that. In MATLAB, if you worried about that, you'd be using C++, if you're being honest with yourself. You should be using C++. Questions on data types? River, you good?
I mean, why should we just save the data one by one? I mean, the difference between name and bunch letters. In reality, which one we should use to define our variable?
Great question. MATLAB is a very forgiving language. In 95% of cases, it doesn't care if you use strings or if you use characters. You can. I could not tell you a situation where it matters in MATLAB. In other languages, it matters a lot more. One difference, though, that we're going to see is when we index through things, and we'll get to that in the indexing section, the way we move through a string and characters to pull items out are going to be very different, right? Because strings had it as one element, whereas characters there were 4. So accessing that data will be a little bit different, and we'll see that in a little bit. But in general, just make sure you if you're doing, start with a double, end with a double. You can't start with a double, end with a single. You'll get an error from that. Just pick one and be consistent. All right. Mike, great job up here. You're going to retire, and we're going to bring River up. And now keep that section of your notes, guys. Beneath it, do 2 more percent signs, start a new section, okay? So now we're going to move on to the next topic, which I believe is, can you scroll up to the top really quick, River? There we go.
Can you just name the section in this line with 2?
Yeah, absolutely. Put the name of the section right after the double percent signs. Okay, so we've done command window, we've done the IDE, we've done variables and data types, basic arithmetic. Let's get into that. Okay, so we'll scroll back down here. New section beneath this. What do you start every section with?
CLC, clear bars, close open.
Boom, Jake, star student right now.
CLC.
Yeah, so get that going. Basic arithmetic. So common things you're going to need. If you want to do multiplication, that's the asterisk symbol. If you want to do division, that's going to be the slash. If you want to do addition, plus. Subtraction, minus. Nothing surprising here. Dasan, how do you do an exponent? If I want to do 10 times e to the 7th power, how would I do that?
Shoot, what's that called? It's like the raise the power little carrot thing? Yeah.
Close. That's for squaring things. So you're right. So for exponents in general, if you wanted to do 7 squared, that's going to be 7 caret 2.
But do you do like an in parentheses? Yeah.
If you have complex things in there, you would do this. You could do more stuff like that.
Okay.
However, e is a tricky one. You're going to actually have to write out exp, so 10 times exp to the power you want to raise it to. That would give you 10 e to the 7th. Okay? So let's just go ahead and do some equations. So give me 2 plus 9 squared minus the square root of 8. And have that output to your command window. You can assign a variable or you don't have to assign a variable. It's your call. How we doing?
I just typed 10 e to the 7 in the command window and it gave me...
Yes, very good. So, naming conflict, MATLAB uses E to be scientific notation. That's why you have to use exp for when you do the E, like the, what's the term called? What's E called? The decay constant or whatever. If you want to use the decay constant, you have to do exp. If you're just using the letter E, lowercase, it's going to be to the power of 10 to the power of.
Okay.
So if you type in your command window 5e10, that's equivalent to saying 5 times 10 to the 10th power. MATLAB will also give you answers, super big answers like that, with this notation. It'll give you 5E10 if you typed a number, like 5 with a bunch of zeros into your command window. It'll give you out 5E10 or 5E6 or whatever that's going to be. Very important distinction there. Decay constant, use EXP. Scientific notation, lowercase e. By the way, if you want some more room to be typing and your command window smaller, you can just click and drag in the middle. You can hide your top tab if you want. If you don't need to click things, right, you should be using Control-Enter to run these scripts. You can just hide your top thing for now, bring it down later. Totally customize your IDE, okay? So remember, we're going to want this in a separate section.
Okay.
So we can put your, yep, and then we want the double parenthesis in between the data types and the equations. Are you guys getting this answer? You guys, what's the answer to this? We figured out square root?
Got 80.1716.
80.7, ... Is everyone getting that? Mike?
17.
You getting 80.17? Is that what you said, James?
Yeah.
Being honest, I didn't run it. I was just writing notes from the.
Okay, run this. Hassan?
Yeah, I'm working on it.
All right, Tomas?
Yeah.
You got this? Okay.
Yeah.
So square root, by the way, guys, I kind of didn't tell you that one. It's SQRT, and then an argument number right in there. So you want to do SQRT and then 8 on the inside.
I have a question.
Yes.
Like if I do the 5 times 10 to the power of 10,
Yeah.
I'm getting this. And I don't know what is that.
So this is 5 exponent.
Wait,
So that's 5 times the exponent.
Uh,
So that's 5e. So if you do 5 exp 10,
that's the
that's the
exponential
equivalent
function.
of the decay constant. So that's the equivalent of 5e 10 mathematically. You can see why this gets confusing.
Yeah, okay, now I understand. So this would be just 10 to the power of 10.
10 to the power of 10, yeah. So that's all your basic. You can do square root of a negative number. It'll give you an imaginary number out. MATLAB can handle I as your imaginary number. That's an error sound, if you're not familiar with it yet. How are we doing there?
Can you put
Okay, so it's
S?
SQRT, square root at the end there. And then you can output it in a couple of ways, right? You can put the colon there and get rid of it, and then you have to type the name again, like River did. That's fine. Or you can just get rid of the semicolon, not suppress it. Your choices. Everything should be stored to variables, though. Always have things equaling variables, and then output those variables. Great. Can you do a double percent sign? So can you enter after this TSLU? Do an enter,
Double present sign.
and then do the double. Yeah.
And
And then you want to do your CLC clear bars after the double percent sign.
okay.
Right, so these sections of code run together. So each section you want to do the CLC at the top, and then run your code with your outputs, and then you're good. And run the code, just run sections, don't run the entire script for now.
Does Control-Enter always just run the section?
Always runs the section.
Oh yeah.
Is that working for you guys? And an easy way to check what variables exist. So if you do Control-Enter in the top and you just have example 2 available, that's only available there. So anything you created in that first section isn't available, so you know just that section's running.
Okay.
Good?
So I only run CLC, so
Mhm.
it will be another section. I don't have to do the rest of these 2 commands.
Can you say that again?
I mean, if I want to run another section,
Mhm.
the only thing I do is these 2 marks and plus CLC. I don't have to do clear bars and close all.
Yeah, so typically if you just have one big script, you just have this at the top.
Okay.
But if you want to continue every time to clear, yeah, because you don't have, so CLC would just clear this. You'll still be left with these variables than if you run this.
Okay.
So that's your choice for how you guys want to operate your code. But typically we want to do CLC and clear bars. And once you start doing plots, we want to do close all as well.
Mm-hmm.
Okay. Matrices and arrays. So MATLAB is the matrix laboratory for a reason, and everything it does, it likes to do with matrices. So to define a basic matrix, let's just call it A, you're going to use square brackets and separate elements with commas. End your square bracket, semicolon. So you're going to want to put actual values in here, like 9.2, -1, 25, and whatever else you want to do. Just go ahead and make a very basic array here. Okay, naming convention is going to be important. This is a 1 by n matrix. Okay, 1 by n. So this has n elements, so it has 4 elements. This is a 1 by 4 array. If you want to do a vertical one, this is considered a horizontal array, right? It's purely values going along the horizontal direction. A vertical array has values going the vertical direction. To do multiple columns, you have to use a semicolon. So you could do 7, 8, 9, like that. Semicolons in here say it's a different column. This is going to be a 3 by 1. Because visually, this then becomes 7, 8, 9. Mike, I got a confused face. What are you looking at, man?
I don't know, I was looking away for a minute.
Will it give an error if we do like matrices that don't work out, or will it fill in zeros?
It'll probably fill in zeros. MATLAB's a very helpful language.
So like if I put 7, comma 8,
Colon 1.
colon 1, it will put
Yeah,
in
why
a
don't you
zero.
give it a try? Do it in your command window, actually. You can just do quick stuff in your command window. Oh, I'm sorry, River, you're good to go back now because you did the last section. Jake, you want to get up here? Continue River's great work.
Matrices is a new section.
Yeah, why don't you do a new section there? Matrices. River gave you a good head start. Can you make this a new section?
Yeah.
And then do CLC and clear bars.
Just like starting from here, just doing a section.
Line 54. Yeah, perfect spot for a new section.
No, it's an error.
That's an error?
Yeah, but that makes sense as well. Perfect.
Yeah, that's good. It should throw an error. MATLAB can sometimes be a little bit too helpful, and it won't throw errors, so it makes your code run, but then you kind of have these unknown, like you have zeros in there. You might not expect that if you're a programmer. Emily, how do you think we do a 2 by 2 matrix?
You start adding in some semicolons.
Exactly. How about right there?
Yeah.
Perfect. 2 by 2 matrix. Because you have 2 items side by side, colons the next row, 2 more items side by side. That's a 2 by 2, so A actually looks like 9.2, -1, 25, 1072 in a matrix. Visually speaking, right? First 2 terms, semicolon, next 2 terms. Good? This on?
So what you're saying makes sense, but I'm trying to figure out how to take notes.
A little odd sometimes, I know.
Yeah.
But semicolon gives you that next row. Okay? You can also define these on different lines. Sometimes that's a little bit useful if you want to visually see how you're defining it. So you can do that, and then come down, do an enter, and then tab in, and then do 25, 1072. So it looks more like the final product. Sometimes kind of nice than having to look along the lines. If you have a really big matrix, you can do that. So just make sure that's working on people's systems. Does that work for you, Jake?
So.
Yeah. All right, another pro tip here. You can see that there's a lot of extra white space in the command window when this prints out, kind of for no reason. I like to get rid of that white space. There's going to be another command you can add at the top. It's going to be format compact. 2 words, and that'll shrink the output a little bit more. A bit cleaner, I prefer it. Or a new section. Arithmetic. And questions on defining these things? This is how we do it by hand. There are going to be a bunch of ways that we can do it not by hand. What if you want a matrix, 100 values going from 1 to 100? Right? You're not going to sit there and do it by hand. So MATLAB has a lot of built-in functionality to do this. The most common one you'll see is called linspace, which stands for, I think, a line space or something. But linspace is going to give you 100 evenly separated values between a start and an end argument. So if we did 20 to 25, we get 100 values evenly spaced going from 20 to 25. Go ahead and do that. Call it different, yeah, call it E, call it whatever. And then you can suppress that output afterwards. This is a good time to also talk about what the heck functions really are. So functions are built-in capabilities into MATLAB that's built to save you time. Every single language that you experience will have functions. Functions take inputs called arguments. And the position of arguments matter. You can't switch these around. Actually, in this case, you can. It'll give you 100 values going from 25 down to 20, right? But the position matters because the first argument in this case will be where the matrix starts, and the second will always be where the matrix ends. That's going to happen for every single function you ever use. So you have arguments in here. This is the function name. And then we're assigning it to an output. This function is essentially passed these two values. The function takes that and gives us an output. We're going to make our own functions by the end of today, hopefully. We'll see how fast we're moving here. Basic function anatomy, okay? Good so far? This next thing's not a function, but it's really handy. The colon, not the semicolon. If you do b equals 78 colon 100, you can read the colon as 2 TO. This is just going to give you values spaced by 1 from 78 to 100. How's that looking, Jake? So you're going to overwrite D there, and that's fine to do, but you'll overwrite D. F equals 78 to 100. So now F is going to be 23. Can you double click this workspace variable over here? Over there and click, yep, right there. Perfect. Another way to look at your variables, guys, in your workspace, if you double click them, it's going to open up a new window and show you all the variables in it, or all the values inside that variable. So here, it gives you 78 all the way to 100.
So it creates
spaced by 1.
It creates doubles, but knows how to move like in.
Exactly. So B now contains doubles. The numbers themselves contains how many of them, Jake? 23. So now it's a list of 28 or 23 doubles. So 1 by 23 list of doubles.
What if I wanted to make it a column instead of a row?
You would need to do. You take B then. In your case, I think you have it as F. You take F. And then you define G equals F prime like that. This is the transpose operator. Single apostrophe for matrices gives you the, I think it's called the transpose. When you flip the rows and the columns, easiest way to do that. Does that work for you, Jake?
Mm-hmm.
Now vertical, so now if you click on that, double click on that variable, boom, vertical values now. And that works for, if you have a 2 by 3 matrix, you do that, you get a 3 by 2 out. It switches the rows and the columns. And square matrices, if you're familiar with determinants, you can just do det, D-E-T, and then the matrices, but this has to be square. A square matrix is an n by n matrix, so it has the same height and width. And you can do determinants on that, in case you need to. It just gives you the product, so if you have values, A, B, C, D, it gives you AD minus BC as the determinant of a matrix. You may not need that unless you're in math class. But just so you know. There's a bunch of functions out there that do these things. If you need help with linspace in the future, where would you go? What would you do, Tomas? What would you do to get help for that linspace function? To see if you're having errors with it, what would you do?
Well, probably click on the arrow if it comes up, or use the tab function when I type in something.
Yeah, MATLAB gives you some hints when you're doing these things. Better way though. Anyone know a better way to get help?
Like Google it.
Google it. 100%. Please do that. We're going to be doing that later in this course. I don't remember half the things I do in MATLAB. I Google them, I find the answer, and I do it. There's no shame in that whatsoever, guys. Otherwise, in your command window, type help linspace. This can be any single function in MATLAB, and you will get the help page that pops right up into your command window. And you can read it there. It should also give you a link to the documentation for linspace. Perfect. So let's go ahead and scroll up to the top of the command window and read this really quick. Linspace generates a row vector of 100 linearly equally spaced points between x1 and x2. Look right below that. You can do a third input for linspace. x1, x2, and n generates n points between x1 and x2. So if we came here and did 10, now we have 10 evenly spaced values between 20 and 25. This is a great way to look at more functionality for a function that you're using, or just confirm what the heck are the inputs, what's the order of this, right? If you just look at this function, it doesn't really make intuitive sense, but you can go ahead and do that. Similarly with that other method, when we were doing b equals whatever, like 1 to 10, you can do a different spacer, and you can do b equals, going from 1 to 10 and skipping by 2. So you'll get out 1, 3, 5, 7, 9. Can you go ahead and run that? And we'll see then how you can generate skipping values as well, like that. Deshaun, how you doing?
Just trying to absorb.
Good. Keep absorbing. Perfect. Yeah. 1, 3, 5, 7, 9. Questions on that? So the colon is actually super useful. We're going to see that when we start doing for loops as well. So linspace, very useful.
What did that last thing do? I didn't get it.
This right here. So this gives us 1, 2, 3, 4, dot, dot, dot. It automatically has a default of a 1 spacer between the numbers. This clarifies. We're going to specify every second. So we're going to go 1, 3, 5, 7, 9. So this would be the same here as doing this. Right? Start at 1, go by 1, 2, 10. Start at 1, go by 2, 2, 10. Cool. River, how you doing?
Great.
Great. Okay, I think that's good. Jake, great job here, man. Really nice work with doing the alternate lines for your variable definitions there, determinants, saving things at different values. Now you can go back and check these things. You can output stuff. Go ahead and type D in your command window and just hit enter. You can view variables very easily that way. Great for troubleshooting. You can also double click the variables in your workspace if you want to see things. So we're kind of working how we use the IDE. You can make this section smaller too. This is taking up a lot here in the workspace. You can drag the columns of it. So if you want to X out of that window and then click right next to the value right up in here. You should be able to, yeah, you can make this smaller if you want. So yeah, shift that to the right and then go ahead and grab the other part in the middle. Yeah, shift that over. Maybe bring it to go back. Sorry. Maybe pull the value to the left and then scooch the whole thing right. So that way you've got better space management of your IDE. Cool.
How do you do the express command? Like if I define this, how do I just express this one matrix again, like in the command? Like how to create the output of G without just leaving.
Then you can just take off the semicolon, or you can do display. Yeah, DISP, and then the variable name. Yep. All right. That's how we define matrices and arrays. Now, technically speaking, an array is either 1 by n or n by 1. And a matrix will be n by m, or m by, I never remember this. m by n, I think. So a matrix just has values in more than one dimension. So your arrays are going to be things of this shape or things of this shape, with values. And your matrices are going to have values in more than one dimension. Okay. Technically speaking, all arrays are matrices. Not all matrices are arrays. Arrays only have values along one dimension. Matrices have values along multiple dimensions. Cool. Cool.
I think you're overestimating how much math I had to take as a geologist.
Oh, good. Okay, let's. Okay, you can sub out Jake, and let's bring Emily on up here, the geologist. And we're going to do some linear algebra now.
Lovely.
So MATLAB, like I said, considers everything to be matrices. So thus it's super easy to do math on them. So let's define a matrix A as a random 2 by 2 matrix. Random is a new function we need to learn here. It's going to be rand 2 by 2. Gives you random values between 0 and 1, I'm pretty sure. And then C, do a lowercase c. This is going to be a scalar as 2. And then let's do, in your command, or whatever you want to put this, just do A plus C. And tell me what your output is. Or actually, Emily, if you'll run that, will be good. Oh! Let's do a new, hey, I have a new section defined there, that's good. And let's do a CLC.
Yeah.
Make sure you have a CLC, clear bars, close all, format compact, everything for your next script there.
Is a random number matrix 2 by 2?
Should be a 2 by 2, random numbers. Yeah. So this should give you out something like 0.7. What's going on over here? Unrecognized function or variable C.
Oh, because I did it
Yes,
capitalization.
very good, very good. So type matters in MATLAB. Height, capitalization, all those things matter. Naming, you have to be extremely specific.
Will it be like pseudo-random, or would it be like the same result cut every time?
It'll be different results every time you run this. Yeah. It's technically pseudo-random, but it's not seeded.
Yeah.
So it's a new random seed due to generate the numbers every time in MATLAB. So everyone's going to get a different answer here, but they should all be values ranging between 2 and 3. We seeing that?
How do we add?
If we're adding them together. Is that what we're getting?
Yeah.
Yeah, random values between 2 and 3. Because this is going to give us a random value between 0 and 1. We add C to it, and when you add a scalar to a matrix, it adds to every single value of that matrix. Basic rule of linear algebra. Let's define B as another random. Let's do 10 times rand 2 by 2. This will give us random values between 0 and 10 now, right? Because rand gives us between 0 and 1. We're multiplying by 10, so 0 to 10. And then we can do A times B. The rules for multiplying things together, you have to have the same, I just call it the central value. So this is A and this is B. These have to be the same value here. So we're just doing a 2 by 2 times a 2 by 2. So these have to be the same. You could multiply a 7 by 3 times a 3 by 9, as long as these two values aren't the same. So order matters of how you're multiplying your matrices together. It's basic linear algebra stuff here. MATLAB will always do that as the default. Emily, are you cruising right now?
Yeah.
Fantastic.
And it's always random numbers between 1 and 0, yeah?
Rand, yes. So this will give you random numbers between 0, and 1. And if you multiply that by 10, each of these values gets multiplied by 10, linear algebra rules. So it'll go between 0 and 10 then. Cool?
That's really cool.
I think so too. That's doing matrix algebra. You can do non-matrix algebra. Emily, let's define a month vector. That's going to have a number for every month. So how about might do it? 1 to 12. So Dasan, what will this look like? Think about it. What are we doing here? We're defining a variable named month, 1 to 12. What is this? What is this going to look like?
I forgot what the colon means. Is that like establish a matrix?
It's going to be an array.
Alright, okay.
Mike, you know?
Is it vertical because of the column?
No. River?
It's 1 plus 12 every.
1 plus 12? Or 1? What are the elements in this array?
Elements 1, 2, 3, 4.
1, exactly. We're just going by 1 from 1 to 12. Alright, so we got month. And then let's define, geez, I don't know, sales as random between, random, let's just do 100 there. Actually, no, 12. Do rand 12. Should give us a 12 by 12. Oh, sorry, do 12, 1. 12 comma 1. See what that gives you. I'm trying to do this. This isn't going well for me. Alright, 12, 1. So that gives us a vertical thing. Let's do 1, 12. We want another horizontal array. I want to show you guys how to multiply two horizontal arrays together. Let's just say that's some percent of sales that we wanted to obtain but didn't, right? So between 0 and 1, so this is some sales percent, and this is quantities sold per month, something like that. So in this case, you don't want to do linear algebra multiplication, right? We've got 1, 2, 3, and then we're going to multiply it by some percent of sales targets that we hit. Right. So in this case, we've got two horizontal arrays. It's not very logical to multiply them like matrices together. We can do an element-wise operation on them. So we multiply this times this, this times this, this times this, element-wise along the way. This is typically what people try to do in programming languages when you're not doing mathematics. Yes, Thomas.
Do we have to specify element-wise multiplication, or will it do it automatically if the arrays fit?
MATLAB will always do linear algebra multiplication. So if you just try to run these two things, it should give you an error when you multiply. Oh no, it won't, because it's the, wait, so it's 1 by 12 times a 1 by 12.
So it should be
Sales, okay, so we'll try to multiply month times sales. Let's do month times sales together. Let's see what happens. We'll get an error, right? Because the matrices dimensions don't agree, right? It's trying to say, we've got a, what is this, a 1 by 12
so it doesn't try to
times a 1 by 12.
doesn't try to
These
push
don't
this
agree,
together.
so it won't do it. To get around this, you can do element-wise operations by putting a dot before the star. Okay, so to do this properly, you'd do month dot star sales. And that goes element by element. So the first elements of each get multiplied together. The second elements of each get multiplied together. The third elements of each get multiplied together. It goes from there. Is that working for you, Emily?
For element-wise operations, do they need to be the exact same dimensions? Like if I had,
Yes. You can try this quickly. Do month 1 to 10. And then see if those multiply together. It shouldn't, I'm pretty sure. Doesn't, yeah, gives you an extra layer there. Perfect, yeah, so you have to have the same number of elements then in each. Okay, so let's do some practical stuff here. Let's get some answers to the equation of y equals x squared plus 4. All right, let's make something more real to what we're doing in our research and stuff. So the equation y equals x squared plus 4. Okay? I want to know what this curve looks like. All right, so we're going to end up plotting this. This one's for you, Mike. We're going to plot this curve. We have to kind of unthink how we're used to doing this, right? You would just normally say, okay, x squared, it's going to be a parabolic, and it's going to be 4 above, like this. And it's a continuous line that we like to draw. When you're programming, things aren't continuous. Nothing's continuous at all in it. Everything's going to be an individual point that we can plot. Okay, so we actually need to do a bunch of calculations, but since we have a computer to do it, this is very easy. So we need to start by defining an array of values that we want to put here. So if, let's say we want to go on our x-axis from -10 to 10. I'll let you guys decide what function you want to use for that. I would recommend two main things, maybe the linspace, maybe the colon. Define some x, okay, going from -10 to 10. And then the y should use that x we just defined, and we're going to get an array of y's. Okay? So the x should end up being a 1 by n, and the y should end up being a 1 by n. Let's see if you guys can get this. These two arrays done. And then after that, plot x comma y. How are we doing?
So,
okay, Emily's going linspace. I like it. So linspace gives 100 evenly spaced values between -10 and 10. And now you're going to do the second equation. Good. Emily's on fire right now. Showing you guys up. Who's going to get it first? Okay, so what are you getting here? That same dimension error? Okay, yep, so we're stuck in this error. Because what's happening here? Remember, these programming languages they're sequential, so they go line by line. So we start up here, we work our way down. X is a 1 by n. If you're doing linspace, it's 1 by 100. If you're doing the colon version, it's going to be probably a 1 by 10. When you come right here in this line, you're multiplying x times x linear algebra style. Okay? Which means it's trying to multiply a 1 by n times a 1 by n. Can you do that in linear algebra? No, you cannot. That breaks the rule because these are not the same. It breaks our rule. So what do? Element-wise multiplication.
should just put a dot.
Just put a dot. You need to do x dot caret 2. Element-wise operations for all these things. Okay, it works for division. You will do a dot slash. Exponents, dot caret. Multiplication, dot star.
You've lost me.
I've lost you. How did I lose you? Where at?
Oh, I don't do linear algebra.
Okay.
So I've defined an x and I've defined a y.
Yep,
and
perfect.
all I want to do is just get.
Well, okay. Careful on defining the y. We don't want to define the y yet. We want the y to be x squared plus 4.
Okay.
Right, so we don't want to define a y as just 100 to, 100 values evenly spaced. We want the y to be a function of x.
That makes sense. So
Yeah.
I'm just defining a domain and then a.
Okay, perfect.
Okay.
So this is where we need to use the element-wise operator.
Okay. Then this is the dot, and where would that go? Just before the
Right in front of it.
multiplication?
Right in front of it, yeah. Right in front of the dot, caret.
Got it.
Yep. And that'll do the element-wise stuff.
Okay.
I got an error still.
Okay. Is anyone else getting an error still?
What's
Minus 53, so it's part of your other stuff is still thrown in there.
But like, why should I?
It's because the S is lowercase and you define the uppercase S for sales.
But I didn't even run it. How? Like,
It'll catch, MATLAB will catch errors in any part of the script, by the way, guys.
so it's compiling errors before.
Yeah, it's not a compiled language, but it sees errors in the script. Okay. Good. So this is where we commonly see that dot coming into play, and it's going to be confusing if you're not aware of this element-wise approach.
It looks like a typo if you just look at
It does look like a typo. Yeah. Oh, look, they just put a little dot in there. Not the case. Not the case. Okay. And then did anyone run the plot XY afterwards?
Yeah.
So to plot things, they have to be the same size. X and Y are both x or 1 by n's. You should be able to plot it.
I still don't get it. Like,
Here we go. There's our plot.
I gotta go back to that. What's the issue? Now I fix that.
Valid expression, check for this.
Is that
What line is it in?
53 still?
53. For now, just put a, just count out that line. Just put a star.
After you're looking very.
Take a look at this at lunchtime.
It's just anytime you're doing element-wise operations, that's it. Anytime you want your array or matrix to like just.
Emily graduated. Great work. What are we on to now? Tomas! Get it up here, buddy. That's okay, actually, I don't think the live stream is working.
Method of thing. But you can't do linear algebra with like a 1 by n unless I'm so it has to be done. Yeah, so I guess anytime you're trying to do something normal and not linear algebra.
We do have some folks in the live stream, very exciting. Alright. Alright, let's move into indices. Indices are how we access individual elements of arrays and matrices. Or if we have arrays of strings, for example. In fact, we didn't do one of those. Let's do string array equals, same syntax, brackets. Let's just do Tomas. And then who's next in Dasan? And that'll give us an array of 2 strings. 1 by 2 array of string data types. We've just been doing double data types for now, but you can do this with any data type whatsoever, okay? These arrays and matrices are just holders of elements. Now when it comes to accessing, right, let's say you wanted to pull out Tomas and use it for something, you need to call these elements out. Indexes start at 1 in MATLAB. So this is the first element, and this is the second element. That's a huge deal for other programming languages. Every single other language starts at 0. MATLAB is the only language that starts at 1. So if you call string array parentheses 1, what do you get out? What do you think you should get out? Tomas or Dasan?
Thomas.
Thomas, it's the first element. You're calling the first element of this string array, which is Tomas. You change that to 2, you get Dasan out. You're simply grabbing elements out of that to use them. It's not very useful in these situations. We'll get into more examples that like really burn these into your memory. We kind of have to start with these super basics though for now. That's how you access elements of an array or matrix. This, of course, is only in 1 dimension though. What if this was in 2 dimensions? So let's make a new variable. Let's give us that random. Actually, let's use another function called I, EYE. Do I of 7, assign that to a variable. This is going to give us an identity matrix, which is all 0s except 1s along the diagonal. An identity matrix. use the word I, like your eyeball, to define that. And then I want you to give me D 3, 3. And tell me what you get out. So now we change this, right? It's two-dimensional matrix now. This is a 7 by 7 matrix. So because it has two dimensions, we have to call two indices to grab a number. This is going to grab us the third row, third column. It's going to go look in D, count down 1, 2, 3, go over 1, 2, 3, and grab that value out. Of course, this keeps going. How are we doing with this? Tomas, how are we doing on the screen here?
Yeah,
new section, indices perfectly, string array, good, I, good.
I just have to work with the American keyboard.
Oh, you're doing great, you're doing great. How's that, Emily? You got it? Okay, alright, we're going fast here, guys. The sound's got it, nice, dude. Awesome. So now what's 3, 4? What should it be? What should 3, 4 be?
3, 4, so third column, or third row, so it would be...
You look in your matrix there?
Yeah. 0.
Exactly. Awesome. Awesome.
I think clear all is a clear box.
The box is cleared by, you're talking about the command window?
My odd XY is still popping up. So what's
Oh,
to
close all at the top, we'll get rid of that. You can also just comment out lines you don't want. If you just want to define D, just put a % sign in front of it. MATLAB completely ignores that. Great way to save code that you might want to use later, but you don't want to use now. Add a % sign in there, take care of that. Mike, good man?
So the first is row, yeah? Third.
Yep.
row.
Yep. And then, one thing that I think gets lost a little bit with beginner teaching is that you can do compound expressions like D33 plus D46, no problem, right? This is just pulling out a single number here. This gives you a double out. This gives you a double out. You can add two doubles together and get an answer from that. All right, so let me do.
It pulls the numbers from the matrix.
Yep. So this extracts 3, 3 and gives you 1. This extracts 4, 6 and gives you 0.
So you just add them together.
You now have two doubles to work with. You can simply add those together and do stuff like that. Super easy. Let's change I to rand. This is going to give us random numbers between 0 and 1. Multiply that by 200. And then let's make this interesting. Let's do linspace D33 D46. See what we're doing here? A little fancy. So, random numbers, 7 by 7 array. So we have 7 by 7 of zeros and ones, between 0 and 1, times 200 gives us random values between 0 and 200. That's D. We're going to pull out the elements at 3, 3, and D, which is going to be some number between 0 and 200, maybe 73, I don't know. It's going to pull out 4, 6, another random number. Let's say it's going to be 123.778, whatever. These are now the inputs to linspace, and we're going to get 100 evenly spaced values between 73 and 123. These values will be different for each of you because your matrix will be different for everyone. But see how you can use inputs now to other functions. Right? Don't get locked into thinking these things can only do one thing. You can do anything you want in these functions. As long as it's the right expected data type of a double, there's no problem.
The random 7 means 7 numbers?
Yes, so rand, you can do rand 7 to get a 7 by 7, or you can do rand 7 comma 7 to get a 7 by 7.
Okay.
MATLAB's too nice sometimes. You've always got options. If you didn't know what your arguments were going to be, you should type help rand, and it'll tell you what what you can do for your arguments.
Where's the...
You go into your...
Yeah, that was the...
You looking for?
I was just looking for
Yep,
the symbol.
looking for the star. Oh yeah, I'm sorry, man. You're doing a great job on this American keyboard. River, how you feeling?
Great.
Does that make sense?
Yeah.
Mike? Yeah, I mean, you can replace this if you had some random thing. You could replace this with 1,000 as well. Why not? It's a double. That's what linspace is expecting as a function. So as long as you give this a double, you can even do a mathematical expression here if you want. How about the square root of 200? Why not? This is going to give you a double back. You're plugging that into linspace as your first argument. There's no problem here. That's fine. Cool. Very useful stuff. So when you start, as these scripts start to develop, you're going to end up with these variables that then you're going to plug into functions. And these can, as long as they're doubles, it's fine. Alright, almost 11:30 here.
Doing great.
This is my first time actually teaching, not on like remote recorded videos online. Oh, alright, take a little bit of a breather here. I have a YouTube channel.
Entrepreneur.
I do. No, okay, so 100%. Let's go to the YouTube channel because these videos are for new people. So the channel is youtube.com/C for channel, and it's called Phil's Beginner Code. If you go there, I've got playlists where all these topics are covered individually. If you want to go back and learn this stuff, super straightforward, okay? Also, if you guys subscribe, one of you is going to walk away with a MATLAB bug today.
Oh, man.
With MATLAB syntax on the mug. Little cheat sheet. So, if you show me you subscribe, we'll enter into a drawing. We'll basically make a string of your names who subscribed. We'll pick a random number. We'll grab that value out.
This is a cheat sheet?
There's a cheat sheet on here.
Just in
I
case
know.
I don't get it, how'd you get that? Amazon?
No, I made it.
Oh,
Are you
man.
serious?
Yeah.
Oh,
Oh.
jeez.
Damn.
I'm actually working on making mouse
Fingers crossed.
pads because these were shipped in styrofoam, which I didn't appreciate. I'm working on getting mouse pads that have MATLAB syntax on there. Selling for like $12.
Wait, so you have like, you have merch, or you have merch, yeah, you have
I
like a
have. I
store?
haven't released the store yet. This is a sample
Okay.
of my merch. Yes. So if you check out the channel, you're gonna see. Could you actually go to the channel? If you just open up, so you're on this computer.
You're making me feel lazy. That's a grad
Oh no. I started this well before.
I
That's
just
two.
took your accurate grenade throw thing.
Oh god. Great thing to put on there. So if you just look up Phil Parisi, even just my name.
Stock
Oh really? Very good.
Just subscribe.
Just do Phil. I at the end. Yeah, I compete with Philly Parisi from The Sopranos for search results.
Gets whacked.
But there, if you click that channel, there's a bunch of different playlists for things you guys are going to want. So the beginner stuff is all covered. Firstly, this 2022 MATLAB course, that's basically everything we're doing right now. It's a 2-hour one. It's a bit more organized because I have more time to just, do individual recordings. And then if you want to, oh yeah, there's the live stream we're doing right now, actually.
Oh,
If
you're
you
doing, you're
yeah,
doing really
so we're
good.
live. If we scroll down a little bit on this page, I've got some Python stuff.
I was a little bit delayed.
These are more like advanced algorithms, guys. If you're looking for more experience with real problems, I'd encourage you to go into this stuff. I've got an image processing series that's out. No self-promo, but also this stuff is there because people like you need to code. So, thanks for watching, everyone. All right, we'll get back to it there. If you guys subscribe, maybe get that mug. We'll see. We'll see.
Definitely you want that mug.
Okay. We kind of got into indexing, kind of fell out of indexing really quick. Let's go ahead and make a string array again with some names in there. Just do a couple names. Let's do Emily, River, and want you to pick a random item out of that. How would you do that? Pick a random item out of an array. So think of what things we need to do first. We need a random number, right? So let's generate a random number. Call it whatever you want. I'll call it selection. Is going to equal a random number. Rand. There needs to be, not from, right? If we just do rand 1, what do we get from that? A random number between 0 and 1. It's going to be a decimal. We want a random integer, don't we? So let's use the rand I function. Randy, rand I is going to give you a random integer. And Tomas, we don't know how to use this function. Let's look it up in our command window. Let's do help Randy to see what the syntax and what the argument should be for this function. Scroll all the way to the top. Keep going, keep going. Help, oh, there it was. Help Randy. So random integers, Randy I max returns an n by n matrix containing pseudo-random values from blah, 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 on the distribution from 1 to I max. So if we do Randy 3, that should give us a value, and n is the number n by n. So if we do 3, comma 1, that should give us a random value integer going from 1 to 3, and we just want one of them. This is where you want to start reading these documentation, because these functions are super useful only if you know where to look for that information. So once you get selection figured out, we need to use that as the index for string array, right?
Is select from like a term?
That's just a variable name. Generic, it's just the random value.
It's not a term in...
No, it's not like a special keyword in MATLAB or anything like that, no. So we get selection out.
Oh, selection.
Selection. And then, does anyone want to fill in what this is going to be right here? What's the argument going to be for string array? So we're doing here, we're trying to pull out the winner.
String array selection.
It's going to be selection. And this is going to assign us a winner. So how I do is I suppress this, leave this unsuppressed so that your winner is output to your command window. And that way you run this script, you get your winner.
So this is a 1 times 1 array of random numbers from 1 to 3.
Yes.
Yeah, okay.
Yes. Cool. Emily, question? You have to rewire your brain to think in the purest, like, base logical form. This is why programming is difficult. It's because no other class is taught in a way that you have to think the way a computer is going to think, super procedural and operational like this. So I like to break problems down into the simpler elements. Like we want to choose a random winner. Okay, we need a random number. Let's get that first. And then once we have a random number, we want to select from this array, so we need to do an index and use our random number as that index to pull out that value.
And you want that as an output, right?
Yeah, you just don't have to include a semicolon, and it'll go to be an output to your command window.
Mine is giving outputs over like sort of on the side here and not in the command window. Is that just
You
something
may have
you
selected
should-
a live script.
Oh yeah, that's totally what's happening. So
Yeah.
I'm in like a live editor.
Yeah, so I don't prefer these, but they are a valid way to code. They're similar to Jupyter Notebooks in Python. What you can do is, if you want to put this in a normal script like what I've got there, just make another new script, and then Control A, copy everything over into the new one, and get rid of that live script. I don't teach live scripts. I don't think they're very useful, personally. Tomas, good? Okay, you can retire.
You're gonna share all that, right?
Yeah, we're gonna. I'll send this out to everyone afterwards. We have the master code. Good work, good work. Dasan, getting up here, man. We've got about 20 more minutes till lunch, guys. Stay with me here. Let's see what's next on our agenda. We've done linear algebra, skipping on functions. Ooh, plotting. Oof. All right, Dasan, come up here, man. Start a new section for us. Same basic commands at the top.
Just a basic question.
Yep.
How do we like change the sizes of these different?
You should be able to click and drag right in the medians of all the. Yeah, there you go. Click and drag for your IDE. Just click on the white space between the two sections. Click and drag, and you can adjust the sizes of everything in your IDE. Let me get rid of this now. Okay. We're going to move on to a different topic now. Indices are super important, we just covered, and we're going to see that more when we get into logic. Right now we're going to talk about plotting. Plotting, before we get into that, we need to talk about the elements of a plot. We've got an x-axis, we've got a y-axis, and we've got data on there. We're going to have a title to describe things, typically in the form of whatever our y versus our x is. A typical name for your title. And then in here, we have to plot things. Is it going to be continuous or is it going to be discrete? Dasan.
Discrete.
Discrete, because everything in a programming language is discrete. There's no lines here. It's always going to be discrete. We can make it look like a line. But at the end of the day, when you zoom in, we're going to be left with individual points that we have calculated, and we're showing it like that. MATLAB has a thing where it can connect these individual points with just a linear line. So if you have enough points, it's going to look like a smooth line. But at the end of the day, we are plotting individual points, okay? So, let's get ourselves back to that equation we had before. Let's define x equals linspace negative 10 to 10. Emily, what does this give us?
That would give us 100 random numbers.
Random numbers?
No, evenly spaced.
Evenly spaced numbers, that's correct. Very good. And then let's get an equation going here for y. Let's make this 7. Let's do something interesting. Let's just do a cosine curve here. Let's just do 7 cosine of
One syntax question.
8 times x.
Do you always need to put the multiplication sign between? Like,
You always do.
Okay.
I've not written it the way you need to enter this into MATLAB. I've just written it what you would see in your textbook.
So we'll complain about that.
Yes.
Yeah. Okay.
Yes.
And
Let's get this.
I don't need to include the dot before the.
Do you or do you not? Good question. Good question. Do you need to include the dot?
Do I get an error?
That's okay. Great. Thank you for doing. Yes. Just run your code, guys. If you get an error, you'll deal with the error. Don't waste time thinking, oh, is it blah, 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 blah. Run it. See what happens. As you get better, you'll be able to get less and less errors in here, and you'll anticipate this. So cosine is just going to look at x. Is it going to multiply x times x? No. Is it going to multiply times another vector or matrix? No. It's going to do an operation on whatever you give it, so you don't need a dot anywhere. Good? Good? So this x is a 1 by n vector. Cosine of that, or 8 times that, gives you a 1 by n vector. Cosine of that, 1 by n vector, times 7, 1 by n vector. No issues. So you should be able to then plot x, y. Yeah? We getting that? We getting that a little bit? River, yes? You got a plot yet?
No, not yet.
Song, good. Now expression. 8 times x. Don't forget your multiplication signs. Good, that worked. Nice, there you go. It's looking a little bit haphazard there. So let's increase the number of points we're plotting. How do you do that, Hassan? Linspace usually gives us 100 as the default. What if you wanted more numbers?
Add that at the end.
Another argument. Let's do 5,000. Give us 5,000 points. We also might need to turn down the cosine. Let's see how this looks. Go ahead and plot that. There we go. Looks a lot better, doesn't it? The reason why I wasn't doing so well before is because it's only grabbing the values that you want along the way, right? Let's change this Dasan, not everyone else, but just Dasan. You change 5,000 to 10. We're going to take a look at this graph. Look at that. This is what's known as aliasing, by the way. You guys, if you've ever worked with sensors and stuff, when your sampling rate is different than the actual rate that the curve's going. Because if we saw that, we'd go, oh, it's going like this, right? But in reality, the function's going like this. But we only sampled it 10 times here, 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 right? So technically, we grabbed variables along the way that were intersecting between these things. It matters how many points you're plotting, okay? Because then those get plugged into your function, and it's just calculating things out. It's not wrong, it's just not displaying the full cosine curve that could be there. Okay, so this is what I mean when MATLAB's just gonna connect. It looks like a line here, but in reality, it's just individual points that's being connected by lines in the middle. To make it just the points, which is what I recommend you always do so you don't get confused, you're gonna add more arguments to that plot command. So plot is a very powerful function. You always start with the two things you want to plot, your x and your y, and then you can add more arguments here. So let's just add, I'm going to do this as a string, just a period here, okay? And do that. Just add a period as your third argument. And we'll see then that instead of a line, we get points. Now, if you're doing 5,000 of them, you might be alarmed because you're not going to be able to see them all. Here we can see them, right? We can see that there's just 10 points plotted. If you put your mouse in the plot figure here, and you can zoom in with your mouse. If you have like a wheel on the mouse, Mike's got a wheel there. You can easily zoom in. You can click and drag this. This is something I'm going to put your mouse in there. Click, hold, and drag in there. You should be able to drag these points around. See, so this plot figure is interactive. You can zoom in, zoom out. If you want to go back to the base plot that you've got, top right of the plot figure, there's that little house icon. It brings you back to the base plot. You've also got zoom in and zoom out functionality there. And you gotta then go over to the, so once you click it, you have to like click and drag an area you want to zoom in on, like that, and then it zooms in on that individual area and makes it the size of the plot. A lot of features here if you want to zoom into stuff. If you want to save this, you can save your figures, top left, File, Save As. Or you might have Save Figure or something like that. Different operating systems are different. We don't need to save it to Sun. But that's a good way to keep your figures for later. Oh, yeah, cool. Nice little bar you got there. You click the color bar option. Yeah, that'll do it. That'll do it. There's tons of functionality. Okay, that GUI has a lot of stuff in the figure tool. You can also do everything that you can in the GUI from the actual scripts and commands. So that's doing as a dot. If you want as dots and the line, you can do dot line. With a little hyphen there. Right, you've got this little character can be a bunch of little strings. Typically, one of them defines the type of dots you want. If you want them to be stars instead of just, you can make these stars. You can make them squares, all these different types of things. You usually have 3 characters here. It's going to be the type of markers you want. It's going to be the type of line you want between it. So you can do dash dash, and you'll get like a fancy dash line. Short, long, short, long, short, long. And then you can also do the color in here too. So you could add R for red. And that's all within a character string. See, that's a little bit fancy, but if you need help on this, how would you get help for the plot command?
Help plot.
Help plot. Let's go ahead and do that in our command window. Okay, so good. So here you can see we have the dashes and the dots there. And your figure still exists, by the way, when you minimize, you click away. You just go click on your MATLAB icon. You can pull your figure back up. This on in the command window, can you type help plot? It also gives you examples in these documentation, by the way, guys. So if you're having troubles, and then let's scroll up a little bit. Nice. Here, this is the money section right here. See all these things? So S for stars, D for squares, V for diamond. You've got M for magenta, K for black, W for white. These are all your different little things you can put together to make fancier plots.
And you don't need to specify in what order you put this
These
stuff.
ones usually you don't. MATLAB's pretty intuitive, so you can like kind of jumble them together.
That's way better than our.
Yeah, it's much easier for plot. I think MATLAB is the easiest language to plot in, personally. You can do super fancy graphs in other languages like R. You can make these crazy visualizations. It's going to be 50 lines long, but you can do it. MATLAB's super simple.
No
Sometimes. No, so you can't type the full, just do R there or something.
Okay.
And then see if we get the red. Should be dots that are red connected by a line. Okay. Alright, I've got a ton of stuff on plotting as well on my channel. We want to plot multiple things. That's not a problem. You're going to use the hold on command in between your plot commands. And then you have to plot something else. You're going to need another XY to plot. Okay? So we're going to need how about a F and a G. Let's define an F and a G. Let's do F as another, let's just do it 1 to 10 for F. And G, let's just do as F squared. Okay? And then we'll do plot F, G, and we'll make those let's do a magenta squares.
So hold on to just keep the last plot up. That's the point of
Hold on tells the figure, which is what you're working in, to hold on a second, because we're going to plot some more.
To
Yeah.
plot in the same graph.
Mm-hmm. From the same graph. So you'll end up with 2 lines on your graph now. Anyone got both on there yet? Give me a hand raise when you've got it. Nice. Jade, double sync here. Killing it. Yeah, Jade,
Ooh.
I'm just gonna make the
Do we have to do F dot square?
I think that's what it's saying.
It's
you
case here.
connect the red squares with
Otherwise,
a
it will be
dash
vector
dot line.
calculation.
Gotcha.
What is MS is assigning the color and the shape, right? Or is MS?
How would you figure that out?
MS. What was MS?
You can also
You
make
wanna
that
make
command.
that one?
You can make the whole bottom part bigger if you want to. When you do that, you can make your command window much bigger. So you can read stuff in there when you do help plot.
Yeah, I can do both.
It's magenta squares, yeah.
And you help
Mhm.
plot in there, and it'll give you all the information you need. Yeah, so very good. So this is a dot operator. River, why do we have to use the dot operator here?
Mm-hmm.
Dot.
Dot.
Operator.
Why?
Because the values in different size.
They're different.
Yeah.
So the dot is what? It's the element-wise operator, right?
Yeah. Just make it function different size matrix to multiply each other.
Mm-hmm. So instead of doing matrix multiplication here, we're going to do element-wise stuff, and since F is a 1 by 10,
Yeah.
we have 2 1 by 10s. Use the dot for that. So that way you're squaring every term in that matrix. Cool? We everyone getting this? Jason, get your dash dot line on there for me. So if we do help plot again, let's do help plot. Take a look. And we want to do a dash dot line. So we'll go up to that money section right here. So there's dash dots. So it's a dash and a period afterwards. So if we add that into our little character array here, so do ms dash dot hyphen period. Let's run that. And now we've just added a dash dot line to those squares.
It's great.
See 'em? So it's a very modular system for plotting in MATLAB. but it's also very specific. So you look in that little thing, you do help plot, you look, I do this every single time I'm plotting for something fancy, looking for whatever it is that I want to do with it, and then you can go in and then plot these things. There's a lot more you can do too. You can change the inside, right? See these squares are kind of hollow? You can go and you can change that color on the inside to be stuff, right? Just something you want to Google. Okay? We also haven't done much with our x-axis titles and stuff, because it's the easiest syntax in the game. You want a title? Use the title command. Call it y versus x as a string or a character. Other one's fine. You want to label the x-axis? X label. Call it x values. You want a y label? It's going to be y label.
Do we need to hold on before that as well?
These guys, no. That's just when you're doing the multiple plots. You have to do that. But you could also just, if you're just plotting one thing, you would do that. These don't get run because they're commented out. And it just runs and then adds these to the figure that you're on right now. Simple way, as I go into sound.
Keep going.
If I wanted to be making like multiple figures within a script, the easiest way to do that would be like these double, what's called exact sides.
That is one way to do it. If you wanted the same section to create multiple figures, all you have to do is use the figure command.
Okay.
So for figure,
Files them and keeps them.
yeah, so what figure will do, if you go to your command window and just type figure like this, it'll open up a new figure. With nothing, it'll be blank, but it'll get you a new figure, right? That's cool. Boom, new figure. So now if you plot onto that, you can do it from your command window if you want. You can do plot FG, go ahead and do that. It's just going to paste that right into that figure. Because that figure is live right now. So that's the one we're going to work with. Until you call another figure command, then that one's live. So if anything you do here will be added to this figure. Default is going to be like the first number, so this will be figure 1. You can call figure again, and any sort of plotting things you do will end up on this figure.
So
And
I
then-
need to be like naming my figures as I go.
Exactly. So you want to do like figure, maybe a title onto there right away.
Yeah.
Super easy. And then you just start to fill this out, right? Title on there. You can also be more specific and you can say figure 1, figure 2, if you want to have more control over what's happening with your figures.
And then everything else got to be in the parentheses of
Nope,
the figure?
nope. So then you just do plot,
Okay.
FG. That's just saying that it's going to be for that figure it's live. So plot FG, title, all the stuff we just said over there goes underneath this figure command and it's stored together. You call figure again, everything underneath gets put on that second figure. And there's ways to do, this is super fancy things. You could do multiple you can have multiple, like, these are called subplots, where you can do like 2 side-by-side graphs. It just takes a couple finagling, but it's not too bad. You use the subplot command for that, surprisingly.
Shock.
Yes, yes. Super simple. Define what you're plotting, same size, plot those things, whatever fancy you want to do with it. Title, X label, Y label. Boom, you've got a graph. Save it in the file, save as stuff. You're golden. You're golden. Questions on plotting? There's a bunch of other types of plots too, right? There's bar plots, there's pie plots, there's 3D plots, there's scatter plots. Tons of stuff. I'm going to refer you to the channel for that one, because I've got videos on each of those individual plots, which will be way clearer than what I can throw together. I even watched those videos, but I haven't used a stacked bar plot in a while. I'll go back to the video. It's a 4-minute video. Watch it. There's the syntax. Boom. You can also go to Google and say how to make a bar plot in MATLAB. The MATLAB help documentation will come up. Click that. Boom. They have an example for you. Take that example, modify it to what you need with your data, and go from there. Okay, we are just about near lunch. think this is a good place to stop for now. We can do some more question and answer when we wait for the pizza.
So these like if else and loops, we're gonna get into that also.
That's going to be in this unfortunate second part of this, yeah. Oh, I wish we can do it right now too. If you guys are feeling feisty.
But
Yeah, sorry, just Son's gonna die up here. Okay, so actually before lunch, we need to talk about one more data type. What are the ones we've learned right now? Emily, give me one.
Strings.
We've got strings. Mike, give me another one.
My brain's fried, I'm sorry.
Come on, data types.
Doubles?
Doubles, yes, we've got doubles. River, give me a data type.
Characters.
Characters. Tomas, give me a data type.
integers or arrays.
Ah, okay. We'll arrays, matrices. They hold these data types, right? They're just containers of chars, of doubles, of strings, right? One we haven't covered is Booleans.
Fancy.
The Booleans are zeros and ones. That's actually like the very base what computers zeros and ones and stuff. A Boolean can only take on two values. That would be 0 or 1. Okay, otherwise known as false and true. Okay, these are what are used in logic statements. Okay, again, this stuff applies to any programming language that you're ever going to work with. Python, C++, Java, maybe HTML has some Booleans too, I don't know. 0, 1, false, true. Okay, you're going to use this to make decisions in your code. So when a condition happens, you want to evaluate it to be 0 or 1 and make a decision off that. Let's say you're going through data and you want to pick out bad data. You know, you're expecting your data to be in the range of 0 to 50. It's strain values for a survey you did. Nothing's going to be greater than 50, right? You get in there and you're going through and all of a sudden you see something that's 1.2 million. That should throw a flag. You should do a check, throw that thing out. And we'll do that in a little bit here. 0, 1, false, true. Okay? Let's get into this a little bit more. Let's do comparisons. So just go to your command window. Let me get Mike up here. New section. Call it Booleans. And we're just going to do some really basic comparisons. Define a variable called x to be 20 and y to be 17. You can do it from your command window. You can do it in a script, whatever you want to do at this point. And then I want you to do x greater than y. And run that and see what your output is. No, don't assign this one a variable. Don't assign this into a variable. Just have it output to your screen.
So I would have to do a bool something.
Nope, just run that command. Now you don't have to specify the types it knows.
But would that create?
It will create a Boolean, yeah?
Okay.
So the output, what do you do for your output, Jake?
1.
1. Any specific words it gave you? So logical. That's right, call them logicals in MATLAB. Booleans are also known as logicals. And that's different than just if you did, d equals 1, right? It stores that as a double, an integer. If you do false and true, it's how we input Booleans to MATLAB. MATLAB will give you just 0 and 1 logicals out. Okay? These are the all-in-one thing here. How about check if x is equal to y? X equals y. You have to use two of them because if you just did x equals y, it would assign the value of y to x, which we don't want to do. So you have to do a double equal sign for that. You've got the not equals to operator. I think some languages use exclamation equals, some use the tilde equals. I believe MATLAB is the tilde equals for not equal to. Can someone check that for me? Yep, x equals good. Let's do a tilde equals. Let's see if that one works.
Has a name?
Yeah, the squiggle. Squiggle equal. Let's run that and see if that works. Yeah.
No. Still says yes.
You want to use just the run section. Yeah, so that should be.
Yeah. Yeah, that's right.
Yeah. So output to these things should be x is greater than y. Is that true? Yes. So we should get a 1 out. Jake, how for the next line? X equal to y?
It should be 0.
0, false. The Hassan, next line. This is okay, this is it. That's a good one. X is not equal to Y.
True.
True.
One.
One. Exactly. Very good.
But I'm actually having trouble making this happen.
Ooh, all right, Jake, can you help him out? So we're going to move into compound conditionals.
Shooting an error up
Call
here.
for pizza.
Oh, is it not split? Is it not a new?
It's interesting that you can just
It looks, yeah, it looks like this is also one section. Maybe they meant to
Yep,
have
just
it
do inline comments like that. Yep.
like
So right there, like,
align these.
You could even do these things side by side if you wanted to just do x equal y, comma, x not equal to y. Right, you can use it on the same line if you want to.
Can I backtrack for a second?
Yes, absolutely.
If I have a matrix, can I only store one type of data within it, or can I have?
yes, only one type.
Only one type of these in matrix. A
Oh,
struct
no.
can handle different stuff, and we'll cover that in the second section of this class if we get there. We are sprinting, but it feels like we're walking. There's so much to this. Like, you forget how much is involved. Yeah, so matrices can only handle one type. Structs can handle multiple types. What's going on over here? You guys getting it?
I'm trying to clear. I kind of. It happened kind of weird, but
Okay.
I'm trying to like clear all that.
So if you run the script, the section that you're in,
Okay.
Control Enter, it should clear everything. Okay, that means you have a persistent error in line 16. So go back to line 16. There's an error, and you can also easy way. Let's count out line 16. You want to actually solve it. It's just your line 36. Right, 36. Here, linspace. Coming out those lines for me, and line 36. But
If you're running the section that it's not in, should that even?
no, errors will still get caught if they're throughout the whole
Okay.
thing.
I guess did you miss a B is on this?
Oh yeah, you need
yeah.
to be there, yeah.
Oh, right here.
Yeah, 'cause
In
you
front of
Before
the
the-
right.
before the
Yeah.
yeah.
No,
After
everything.
Okay.
That's it.
Pizza should be coming at noon, so we'll see.
Oh.
Okay, so that's just simple comparisons, one item to one item, you get the Booleans out, or the logicals as MATLAB likes to call them. You can also do compound statements, so let's do an x, y, and a z here to be 84, and we're going to talk about and or. So and requires both things on either side to be true to give a true, okay? Or only requires one of these things to be true to give a true. However, MATLAB doesn't like to use the words and or. Python does use those. MATLAB likes to do the what is it called? The ampersand, the squiggle thing like that. And then or are these vertical bars. Okay? You have to probably find those on your keyboard. They're not super obvious. But those are going to be your and or operators. So then if you did x is greater than y and z greater than y, try to run that. Yeah, good. So logically, what should this evaluate to? Tomas, is this true here? X is greater than y?
That's true.
That's true. We get a 1 from that. And then what about this?
That's also true.
Also true. So that this whole thing should give us a true. And if you did or, what would we get out?
Also true.
Also true. Conditions don't change. Alright. Let's do I want you guys to have that in. We're gonna do this next one here. Should be that should be our pizza.
Let's see where priorities are lying.
Hello. Hey, fantastic. Where are you at?
Are you done?
I learned a little bit when I was doing the physical oceanography online back in
Okay.
2020.
Are you all like grad students?
Yeah.
But on different curricula.
Coincidentally, the
We're
three of
all
us
in
are
the
in the
same
same lab.
So you're all here on campus? Cool.
So for oceanography.
I didn't see your other video.
And are you in engineering or?
Yeah, I'm in my office
Yeah,
or
I'm up the
something.
other side of campus. And Jason and I are brand new, like first semester.
Yeah, you did. Right.
And,
I'm an exchange
Oh,
student,
yeah.
so I'm second year.
Okay.
Yeah. About first year.
I Ruse well.
Hi, nice to meet you. Did you go to the boat burning?
Mm-hmm.
Oh, yeah.
It was good.
Was there?
Lots.
I thought it's
I
cool.
was just asking Josh about you yesterday. I was like, have you talked to Emily in a while? And he's like, no, I really haven't. I was like, we're bad friends.
I'm a veteran.
And I was like,
We should have really.
we might be bad friends. So it's really funny. I was like, oh, I'll call her tomorrow and see what's up. And then I saw you this morning, so I was like,
Go on.
yeah.
I was gonna ask you, I'm used to doing a PhD in code and doing any of it, where spaces are very important as you do like between things. MATLAB, does it care? I don't think I've been doing consistent, I'm not like putting spaces before and after
Yeah,
operators
neither
and
have
stuff.
I, but it doesn't matter.
Okay.
Like it's like here, like I put a space in between the people on either side.
Okay. Cool.
I find MATLAB to be pretty intuitive. Like
Yeah.
R always felt like, I don't know, awkward to me.
Multiple different packages that have different like things for each package. That's the part that bothers me.
And
It's like,
it's really restrictive of what you enter.
Yeah.
I'm not really good at that. But I also did Java. And Java is just way chunkier to handle. But I mean, like, we're not doing real algorithms yet, so it's like hard to tell.
we have models in my lab that I inherited when I got hired in it, and I'm gonna have to like
I have
look
the
at them when they
drive
break.
of the beach survey graphs that have not been touched since 2008.
Right
And
now I have
was
stamina
told
for
to
plotting.
figure
That's
out.
it.
But like, how hard is it to get into the oceanography school? Because like, I have no clue. Outside the US.
It's competitive, but
Great question,
I
right?
didn't really. I know I applied even though my grades weren't terrific, and I got scouted by my advisor Candace. I applied to a different lab, and she was like, I want that one.
It's up there. It's not
Yeah.
MIT or
No, I mean
San
we.
Diego, but like
What was your class size? Like 30?
for my class,
Yeah.
yeah.
Yeah,
They're
so
like 30
I don't know how many applied, but I know it was more than 30.
There are only 11 of us this year.
But like, it's not so small classes, so like.
No, I well last year. I mean, I think our fifth PO class had like 30 kids in it. It's pretty great.
almost 40.
Yeah, but the year I started, it was the year before you. It was the largest class size GSO ever had.
But that's PO grad, right?
No, just in general, the whole.
Oceanography
So
and
within
all 4 disciplines.
oceanography, there's physical, geological, biological, and chemical.
I think the PO is way more
My cohort
competitive.
has a ton of PO. Also, we just have more physical oceanography faculty than any other type of faculty. Like, I think if we have a specialty, it's open water physical ocean.
Mhm.
I really wanted to take physical oceanography, but just stumbling through course coincidences, I dropped it. Like, I really wanted to take it.
You could probably still enroll.
Yeah,
Matt is TA,
I had
that's
already
Really?
enrolled.
Oh, that'd be good.
And just I exchanged it for research credit
Yeah.
now. And now it would just cost money.
It's a cool class. I know people before had said it was terrible, and I really didn't love taking it, but it was good to take.
I struggled through it because I'm just not. We both.
I'm
we
not
have
math
our-
brain. Nope.
But by the end of it, I was like, oh, I know how the ocean works. This is
I covered a lot
worthwhile.
of it.
And that would have been like something interesting, like climate interactions, because like in the end I'm going to be dealing with the results of that a lot.
Whose lab are you in? Do you work with
With
robotics or?
Kitty,
Julian?
Okay. Hi. This is Toby. He's my roommate.
Hey, Toby.
So maybe the room will heat up a little more again. Like it's always cooled down.
Oh, close the window if you want.
No, I think it's the air conditioning that makes it so cool.
It's like automatic.
On a hot day we would get in here.
So we migrating.
I like that yellow on
What?
Your yellow.
Oh, I thought it made me look green.
I just,
No, I didn't even bother to look. I was like,
Oh,
it's not.
The slot
You know, like
stuff
I see
was
over
really
here,
helpful.
it's
Not
like
super
it lasts
easy.
forever.
Yeah,
I was
but
like,
like just I've never done it.
I
I'm
just
worried
like sundress that's like yellow.
to wash it though, because I think it's gonna, which is a bummer. Then we'll have to pass on to something
How
else.
is there no wash?
Could try, or I could let it dry, but I'm not so good about sorting. I just like, I open up the dryer and I go, oh.
Yeah, that,
That's fair.
I just recently started taking care of my lights properly.
Oh, good job. I'm so proud of
Because I
you.
own so few of them. I'm like, color went in with all the colors.
I have white sheets, so that it forces me to do too much when I go to laundry. Do you have laundry at your place?
Yeah. You want to do free laundry? Just
I
come
do.
over.
Is this how we're gonna maintain our friendship this year? Is
I-
just come over and use your
honestly?
laundry? I'll bring you baked goods.
That,
Sorry,
I think
can-
this is a really good
I think this
barter
will work.
system.
Yeah.
Yeah.
How's the roommate? Is it still the same?
That's
guy?
cool. He's a cool guy. He's there's something a little bit
I think Josh has mentioned that, like, who knows how his separation is gone? It's not your business, but he's
yeah,
probably
that's
not
the
a
thing
good
that's
guy,
a little
but
like,
it's-
you know, because
but
it seems like he has a temper, but not for us.
Okay.
Definitely
That's okay to live with.
for the divorce, and I'm like, well, that's kind of how that goes. So,
Yeah.
but he's like super friendly, and
Oh, this one looks
I don't
good.
know, he always says hi. He's a nice guy.
I'm actually really bummed that I dropped that class a little because it's like my friends from last year. Like I
Do
only
you know
them.
Elin and Felix?
Yeah.
Okay, Elin was in my group project for that class.
Nice
Yeah.
to meet you.
Elin was really cool, right?
Yes, she was awesome.
And she,
Are they still on their road trip?
they're currently coming back.
Oh, are you the guys who are getting a car from them? I talked to, I think maybe one of your friends.
We got the car from Rhode.
I don't,
Like,
okay,
one of the civil engineering guys.
alright.
I'll talk to Josh about it. I don't think he'll mind, but sometimes weird things bug him. So
That's fair. It's
so I'll ask him about it, and then I don't want like or whatever not.
A little bit better there for the lighting. Sorry about that, guys. No, that's much worse. Yeah, I'll have to work on it. I'm sorry, guys. First time trying this, but I appreciate you being here.
How you doing, Jake?
Well,
Is this a lot? Is it going fast?
yeah, it's a lot, but it's good. I think I'm good to handle on everything we've done.
Yeah, you seem like you're one of the more advanced.
Yeah,
People
I
are-
have some experience with MATLAB just from like the physical oceanography class, but
Mhm.
I never did like any of like the for the Argo flow project. I didn't do any of the coding or anything, but I did
Yeah.
use it like a lot of the standard functions. Of the
Cool. Nice. Very good. Jim! It's just stopped working. I don't know what.
Must be
Well,
the heat.
it was super quick actually after you left.
Oh yeah.
And I think it was something with like the power. Something was weird. It just turned off, and then I switched outlets, and nothing happened. It was super weird. I don't know what's going on,
I
but
think it's
I bet you it would work now, because it's cool.
probably would if we plugged it back in.
But I
But
tried just as an experiment.
just to experiment, yeah, we can do that. To see if for knowledge.
Say,
I don't have a cable to. It's because I'm using that with the TV.
no, this.
Oh, we can just go straight to that.
Right.
Well, no. Oh yeah. Okay, plug that in. See what happens.
I just want to see if it works. Okay. Now, on is.
Right by. It's the only one that's not labeled here.
Oh.
But before it was flashing on us, but it's not even flashing with that.
Okay.
Something was weird with that.
All right. I sent a note to Lauren and Jason, who are
Our substitute text
our
here.
substitute text.
Nice.
So they will.
Nice.
This is nice. I'm sorry about the trouble.
No, this actually isn't too bad. It's working okay. We've recovered.
Good.
welcome.
Because I'm always in South Lab to get equipment and stuff. I don't know if that's what it's actually called, but
South Lab.
it's just
Middleton?
across the, yeah. But yeah, big old wave tank.
Yeah. Hopefully a new one. It just got repainted. That's the smell.
Yeah, lovely.
Just,
So ready.
yeah. Hey.
Hey.
How you doing? Are you Fiona?
Yes.
Have a seat. Welcome. Glad you could make it. Yeah, sure thing. Sure thing. It's been an aggressive morning here. We're all over the place. But we should be alright. So we can do our rotation here. We have people come up to the front and code onto the screen there.
How do I save like a script?
Top bar. You should be able to go to the Home tab or the Editor tab.
Oh, save workspace.
No. Go to Editor. And then top left, you've got the Save button. Use that. You can do Save As or just Save.
What files are you save as?
They're all .m files. Yep, and you can open it with a text editor. You can do whatever you want with it. It's just the one that MATLAB knows to use.
Are we going to continue at 12:30?
Yeah.
Well done.
Yep.
So do you want to go in my office? But
Oh, sorry.
I'm gonna show you guys a little game that I made in MATLAB. That might be a
Whose
lot.
lab do you work in?
Chris Roman's lab.
I've asked you that probably 20 times now.
Oh, that's okay. Okay, so this should hopefully kind of give it. Personally, it's hard to teach and learn programming with all these really simple examples. So this afternoon, I want to get into more example-based stuff, like checking if a number is prime and making a separate function that does that and gives you an answer out and stuff. And we can learn the functions we do along the way, but I think we can be done with the super basic examples that don't go anywhere. You know, if you guys can think of anything too, and in your research, you're trying to do scatter plots with some data, we can make some fake data and stuff like that. Be more useful. Do you work for Noah?
No.
Okay, let's make sure.
Oh.
I was like, maybe she's from the lab across the street here. But this was just a fun game that I did, and it takes in a bunch of. Oh, hold on here. All right, great learning moment. You have to be in the same file as all your stuff, otherwise it won't. Things won't work. So I got to bring in the layout again. Default layout. I gotta navigate in my current folder over here to where my files are stored. So the way this works is I have a bunch of separate .m files that are all my functions. So I have to go into this folder here, and I've got all these .m files that do specific things. That way my main file isn't just chock full of hundreds of lines of code. I can easily call functions in here, like, so I'm basically, this is a tank game. So I spawn tanks on a battlefield, and then as we go in a number of rounds that I define right here, blah, 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 some other setup stuff, I can check moving a tank. So I can move a tank right here, and then I can regenerate the map that they're on. So now it represents the new tank positions. And then I can move the tank orientation of the left or facing right, generate the map again. I can move the tank angle of the gun. I can set the launch speed for the tank, right? So I can do that and iterate over all the different tanks on the battlefield, and then I fire a missile, shooting a tank, calculate a kill zone, check if there's any tanks in that kill zone, and then subtract health from them, and then you keep going around. So this is actually kind of a fun one. Let me see if I can run this though. All right, cool. So this is all based upon this and then a figure. So here's the little map of the tanks. So I've got 3 different tanks, and you can see that they're also got lives on here, how many lives are left. And then the whole thing is, let me like shrink this down to just be in the, there we go, some side-by-side action. And then get rid of this here, get rid of this. Alright, so it's purely a command window usage, and we're taking user inputs. So I have all the stats of my current tank. So I'm at whiskey glass. So I'm at this tank here, he's at this position. He's oriented facing left, launch angle's 45, launch speed default set to 1, so I can move him a certain number of meters. I'm trying to move him 15 meters to the left. I have a set in here, you can't move them more than 5 meters, so let's move 4.2 meters. Boom. So he shifts to the right there. Can change his orientation. I want him facing left. And launch angle, let's just set it to 60 so you can see it shift on there. Launch speed, let's do 10. And then it does a little animation like it's shooting. Pew! No one hits, goes to the next tank's turn.
Wow.
So this is using a lot of the stuff that we've been talking about. It doesn't seem like it, but each of these tanks have variables contained in them. We're going to go over structs, but they're a struct, but they contain a position, which is just a double. They contain a health, another number. All these checks I'm doing are if, we'll get this in a bit, but like it's checking your position, tank position, equal to kill zone, right? Giving a true. If that's true, then I make an action based off of that. It's kind of the sequential logic flow that you have to build in, but it's using all the stuff we've been covering so far in this class. The plotting, this is just actually one graph, okay? I'm plotting individual squares. I'm plotting a line that goes from the square center location to an angle, which is just some trig, so you can do like an angle, and then you do trigonometry. I'm pointing these two points here as a solid line. You can change the thickness of the lines and everything like that. You can put text on graphs like that. Exposition is just an X label, title, put it all together. Come into a fun game. And the plotting, the way I'm doing that, so it's like the animation plotting. It just plots from 0 to 5, then 0 to 10, and then 0 to 15. Scale it out, shows different parts of it. Kind of fun. All right, thank you.
Thank you.
I will post this whole thing online. Otherwise, I recommend looking at I have a whole like 2-hour video that goes over then the rest of the stuff you guys are gonna miss. Hop into there. Take your time learning it. Thanks for coming. Sorry we didn't get further. Hopefully we got some good fundamentals in.
I don't know how to say thanks if you ever want to, count microplastics and stuff. That's a skill I can teach.
That's a tempting one,
I
yeah. Cool.
Are we in the running for the mug, or
Did you guys subscribe?
I subscribed.
Yeah, I'm
You're gonna subscribe, or did you subscribe?
not yet, but I'm going.
All right, so you're not in the running. Did River, did you subscribe? Did you subscribe?
Yeah.
Did you subscribe? Right?
Oh, yeah.
Emily, did you subscribe?
Not.
See? All right,
that's
it's pretty.
pretty-
This is actually pretty close here. We got. We can do this right now. Uh-oh. So let's do this is terminal. Names. So we've got Emily. Oh, you didn't, Emily. Sad. You did, right, Jake? We have Jake in here.
Maybe I just want one of my new students to get the mug.
Oh, wow, that's really generous, Emily. We've got Jake. We've got River. Hassan, are you subscribing really quickly there?
happening? I have no data.
Jake is supervisor.
Hassan. We've got Mike. I wonder if because we'll just do it right now. We'll give the mug out. Do you know if are they around? Can you yell Tomas? Pressure's on. Is it Tomas in or not? We don't know. I would lie if I wanted. I was smart. Tomas, did you subscribe to the channel?
Yes.
Okay. So we're doing the drawing right now for the bunch of people are leaving.
Are you gonna do like a?
I'm doing it right now. There's a little.
red light drawing.
Dude, this is depressing. I have no data.
You want to do the Wi-Fi here?
Yeah, that's an idea.
You happen to get them like on that system, it might also
Alright.
take some time.
Wait, no, yeah, it's connected.
Should have asked you guys what the syntax was.
Oh, it's Mike.
It's Mike.
Oh,
That's the fourth
really?
one. Yep. Congratulations, Mike.
Oh.
New MATLAB bug.
Can I just have a
This is
look
like
at this?
something of a commitment now. Yeah, go ahead.
I have to get good at MATLAB too.
Yeah, it's kind of pressure's on.
That's so
We
cool.
gotta decide if we
Man.
wanna do that.
Thanks.
Thank you.
Very nice.
So it like lists the functions of like,
And it's all your little functions out there. It has like a list
That's
space,
helpful.
1 to 10.
Yeah.
Yeah, you want
Yeah.
to set this back in there?
Yeah. I will leave it out.
I appreciate it.
Thank you, Bob.
Yeah, thank you.
Best.
Really,
Take
bye.
care.
See you guys.
You're gonna
Thanks, Tom.
very professional.
Good luck out there, guys. You've got my email. If you have questions, you can just email me. I might send you back a video, but it'll get it done for you. You know. Okay, clear. I think Mike's coming back. Okay, where are you at with MATLAB? Skill level wise.
I used it a lot in undergrad.
Okay.
It's been 2 years since I.
2 years. Oh man. Okay.
So I'm a little rusty, but I remember how to do basic things.
Great. Okay. We're going to be jumping into control flow here, which is if statements,
Oh.
for loops, while loops.
Yeah.
How are you experienced with those?
Yeah.
Great. So we lost a couple people. I'm not still here. Annoying. Okay. Is there anything you want specifically learn today?
No, just a review of
Okay.
what it is.
River, you were talking about doing machine learning.
Yeah, I'm
So-
curious about it a little bit.
Yeah. MATLAB is not the language you want to use for machine learning.
Oh, okay.
What you learn will help you in doing machine learning tasks, but I'd recommend you do Python.
Okay.
That is because the open source community around Python
Mm-hmm.
is much stronger, and they're the ones making all the functions for machine learning.
Okay.
Yeah.
Python's free too.
Python is free. Absolutely, that's a huge boon. But also things like TensorFlow, Keras, PyTorch, these are all the main packages you're going to be using anywhere out in industry, and those have Python APIs for them. So it would be a sin for me to teach you machine learning in MATLAB, because then you're going to go out and no one's going to use it like that, right? So since we're on that topic, you need to make sure you're using the right tool for the right project. Right? I can use my iPhone as a hammer if I really wanted to. It'd break the iPhone, but it'd do it, right? But it's that notion of using the right tool for the application. So MATLAB is really good at a couple things, and this is all my opinion. Plotting is super easy in MATLAB. I don't think it can get much simpler. We just covered plotting, Fiona, you just missed that unfortunately. But it's literally like, you want an X label, use the X label command. You want to put a title on there, use the title command. You want to plot something, use the plot command. You want a new figure, use the figure command. It's super straightforward. You want to do a bar plot, bar command. You want to do a histogram, histogram command. Super straightforward stuff. Plotting's great. Linear algebra. MATLAB's fantastic. It's literally the matrix laboratory for a reason. All the functions, everything is built for matrices. Okay, so I recommend any sort of you're doing inverse matrices, you're doing determinants, you're doing any linear algebra stuff, MATLAB's fantastic for that. If you're doing any other stuff, I don't recommend MATLAB. I would recommend Python, I'd recommend C++. If you're doing stuff like with your operating system, you're doing a lot of you're opening up files, you're changing things, you're resaving them, MATLAB can do it. Python's probably a little bit better. That's probably a near extension. Just use MATLAB if you're already in MATLAB. But stuff like if you want to go and web scrape, don't use MATLAB. Why would you? No. Python's got packages that are built for that to go and do it. Now, that gets on the topic of what do you get in the MATLAB install? So MATLAB, when you download it, gives you a bunch of functions like we've been using. Things I haven't talked about, like summing. You can just sum the array, if you have a matrix, you can just sum the values. It just gives you one value out. We haven't talked about the length of a matrix. So if you have a matrix and you do length, it gets you the longest dimension. So if this is a 2 by 3, it'll give you 3 out. If you do height, it'll give you the height of the matrix out, which is 2. Right, so there's a bunch of just built-in functions in MATLAB. What you'll notice is that other languages don't necessarily make it this easy. For example, in Python, you have to import a package called NumPy. So in Python, you have to import a package. And then to use those type of functions, you have to do numpy.len. So you call the package plus the function you want to use. That's for Python. In MATLAB, it comes with a bunch of these functions already, and Python does have a couple functions too. But this is comparable size. If this is MATLAB, Python probably comes with like that many built-in functions, because it's all based off these packages that people create and maintain, improve over time, that you can utilize. And also, if you downloaded all the Python packages in the world, your computer wouldn't have enough memory. Right? It would be, it's bigger than this entire, size-wise, it's like you'd need 2,000 of these whiteboards to visualize the size of it or whatever. MATLAB also kind of has packages, but instead it calls them toolboxes. So toolboxes are how you extend the capabilities of MATLAB. For example, the range function, which is kind of silly in my opinion, but the range function isn't part of built base MATLAB. You have to download a new toolbox into MATLAB. It's the Statistics and Machine Learning Toolbox. And when you try to run that command in your command window, it'll give you an error and it'll tell you this function is a part of XYZ toolbox. To install that stuff, if you come up to your IDE for MATLAB, there's an add-ons button right here. Home add-ons. And see, it even tells you, extend MATLAB capabilities with MathWorks toolboxes, hardware support, community submissions, etc. You'll go into their little drop-down, search for whatever package you want to install, toolbox it's called, and then you can add that to your MATLAB installation. And then use you don't have to do machine learning dot range. You can just use range, right? You never have to use that dot notation like in other languages. MATLAB just has toolboxes, brings in the functions, and you're good. Okay? MATLAB is also, as someone mentioned I think earlier, you got to pay for this. And of course we're on university licenses here, but as an individual, if we graduate, you're probably not going to buy MATLAB. It's some like couple $100 for an individual license. You can do a 30-day free trial if you need to use it for one thing really quickly. But this is kind of a little bit of a flaw in MATLAB's business model, in my opinion. Right? So MathWorks is the company that owns MATLAB, and they're the ones who maintain it. But the reason why this even exists is because back in like, I don't know, maybe it was 40 years ago, something like that, a couple of professors made MATLAB, and then they made MathWorks. And they are able to give legitimate support for the language. That's the benefit. That's why you're paying money, is because you get this support. Right? If you have problems with Python, who do you talk to? Some random YouTuber, right? You go on YouTube, you go on Stack Overflow, and then you figure out how to solve your error. If you can contact MATLAB support, and they will respond to you. That's the value for companies. It's also a little bit better with versions over the years. Less conflict with things. Python, for example, went from Python 2 to Python 3, and there were some big changes in how scripts run. So you couldn't run, potentially, you couldn't run a Python 2 script and now your new Python 3 interpreter. It's not compatible as well. Some big changes happened. MATLAB tends to make things pretty good.
Our lab uses a titrator to look at alkalinity, so we can look at things like CO2 in the water or try to figure out how much carbon is produced. That's probably a little, whatever. Anyway, we use that value. So we have an R code that we put in our titrator information, and it gives us a value for alkalinity and alpha. We import that alpha into our MATLAB code as one of the variables. So we need both of these in order to do it, and we're using different pieces that were created by different scientists. Last year, they took out the alkalinity variable from R with no replacement And in their yearly thing, they said, we got rid of this with no reason why. So we don't know why they got rid of it, and it's one of the things that we actually absolutely need to calculate for our seawater package in MATLAB. So that's to the
great
credit of what you
example.
just
Yeah,
said. They just, the group that created it said, yeah, we got rid of it.
It's brutal.
So
right?
now we have
So-
to find a workaround.
And that's the open source community, right? Usually a good open source community will maintain that stuff, they'll call it legacy. They'll say it's going to be depreciated and will disappear, but like they'll give you some time and give you a way to use it. Notorious other offender of this is OpenCV for Open Computer Vision. They are horrible at, they'll change like the order of arguments for a function, and then all of a sudden your code's breaking because things are flipped. It's like, why did they do
Code you
that?
always use, yeah.
Why would they even have thought to, like, it's painful. So sometimes the free software has those disadvantages. I'm not saying that makes MATLAB better, you can always pay for these things. Just acknowledging the two sides of the coin that we're on with programming, and pros and cons to both. So, questions there? Cool. Okay, so these functions are included along with hundreds more. If you need more, add a toolbox. All right. This afternoon, we're going to start with control flow, which is really if statements using those Booleans we talked about right before lunch. And then we're going to get into for and while loops. And then after that, we're going to kind of open things up a little bit. We're going to try to write a script that checks if a number is prime. Okay? If statements have a general form starting with if and then a condition. Okay? The condition is going to be your Boolean statement, like if x is greater than y, print, that's Python, getting confused already. You're gonna do display x is greater than y. Very simple, and then you have to end all of those statements, okay? If, end. Condition, actions to take. So of course, before this, you need to define an x and a y. If we do x equals 20, y equals 17. Actually, River, do you want to take the computer? I think Mike already went, right?
Yes.
At the very end. So River's up. Let's do a new section in our code now, and we'll start getting this stuff programmed. Get this?
Yeah, I'm just tired from.
It's a tiring day, man.
Oh, it's just a pizza.
It's
Oh,
just-
That's actually pretty fun pizza.
Toby.
Oh, sorry. I'm sorry, River. I don't even have you in the old. Let me take care of
this
that
is
for you. I'm
command.
sorry. We're all the way in like no man's land here. Let me get back to that script we had. Shit, where was that? Let's see.
Is this in Linux?
Yes, this is a Linux computer.
Cool.
I thought I saw the little command prompt up there.
Yeah.
Yeah.
I don't know where I put that other file. Shoot. There we are. It's on the desktop. Okay.
Linux is fun, but sometimes you can take hours to find something. So just installing a program can be quite daunting.
Actually, one of my most popular YouTube videos is installing MATLAB on Linux
Yeah.
because of that exact reason. Okay.
It's not always hard, but sometimes it is.
Yeah, exactly. It's either one command or it's 1,000 different commands. Okay, so we just finished that up. Start right here. CLC, clear bars, close all type of thing. And then get this in here. Mike, you got this in?
Yeah, I used end, but it shot me an error for dropping that again. Oh, I didn't finish it, that's why.
I'm not sure if you need, I like putting parentheses around these things so it's contained. Parentheses just make sure you're doing almost like an order of operations. So make sure that you evaluate this part first, and then you allow if to take a look at that. So what's really happening here is, if the if statement evaluates to 0 or to 1, right? Those are the two cases that can happen here. So it's if this evaluates to 0 or to 1. So if x is greater than y, x greater than y is going to be true, right? X is greater than y. So that will happen this time, and if that happens, then in our command window, we should output x is greater than y. Alright, that happens if this is true. If it's not true, nothing happens. Is this running on people's systems here? How are we doing? Great. Okay, if we run that. Control it. Oh, you have to define x and y. Yeah.
How do you call these decisions, if and y, in English?
Conditional statements would be a good term for it. Conditional statements. Or it's all part of control flow. Get this typed, and then you should get something printed out to the command window using the disp command. Will you be there? Fiona, how you doing?
It's working.
You have that output?
Yeah.
You too, Mike? Mm-hmm. Okay. Awesome, guys. Awesome. Oh, and you can see, look at, wow, River just excelling right now. So you can add an else statement, because if it's evaluated to 0, nothing happens, right? So if we change x to be 10, this is false here. We get a 0 here, and then this code is not run. We skip to the end. So nothing happens. What River's doing is adding a condition where if that's true, this happens, else we're going to display that y is greater than x.
That's not always true though.
Very good, because what condition are we forgetting?
If x is equal to y.
Exactly. So if x were equal to y, what would happen? Is this going to be true or false?
X would be false.
It'd be false, and we come down here and say that, which is wrong. Right, very good. So it would be more proper to say, if x is greater than and equal to y, let's do that, greater than equal to y, then we know for certain that x is greater than y. Right, so that's true, this is for certain, x is greater than y. Otherwise, we can say that x is less than y, or y greater than x actually works.
No, then you're making the first
Oh, x is greater than or equal to y. Greater, equal, y. That'd be the most accurate way to do this. And display, I believe that command is double, so you can do full-on display, or you can do disp. I believe the preferred one for MATLAB is disp, but they've kept display for legacy purposes, so that when Mike tries to use this 2 years from now, it's not just randomly removed and his code can't run. They keep both for posterity reasons.
And do we have to put end?
And then, sorry. You always have to end these statements. Python, you don't have to end these statements. MATLAB, you have to end these statements. River, what's going on?
I just want
Okay, so you don't want to do only one end at the very end. Get rid of your middle end there.
Okay.
And then, you're already jumping to else if too? Jesus.
Oh, this is the equal.
Okay. So then you can do another condition. But you have to build that into your flow. So, okay, so let's just confirm here what happens. So if statement, if this is true, you do this. Otherwise, if that's not true, you do this. Okay, so if this is true, else you do this. You can do another thing in here called else if, and I believe the error you're getting, River, is because it needs to be one word. Else if should be one word, and you have to provide it a condition. You're doing another else statement in here. Another if statement. So then if x is equal to y, and you're going to display they're equal. And then else display else we should display that y greater than x. That's how you would do the fullest of full if statements. Now you can do as many else ifs as you want. Okay? You could just continue doing these over and over and over. You can only do one else and one if. Okay? How's that going? Hold on there, Mike. Are you getting that?
Yeah.
So you have to, when you do an else if, you have to give it some actions to do. So you want to do right after the. Okay, so else if. When you do else if, it's like you're doing another if statement within it. So you have to give it a conditional right afterwards. You can't display it. You have to give it a conditional, else if this condition, then give it some actions on the next line. Okay. And then your else is like your catch-all. Everything else was false above it. Else catches everything down here and then gives you some final output. Good, Tomas, you good on that? Yeah. Okay. Great. I'm also going to tell you about, we'll cover switch statements right now. So you can keep doing these else ifs, right? You can do another one, all you want to do. That gets kind of messy. So another way to do this is with switch statements. So you have to define a variable to switch on, as in you use it as the switching variable. So you define switch on x, and then you would do cases. So case of x equals 10, you display x equals 10. And then you have your catch-all is otherwise at the end. So it's kind of like a modified if statement where, remember how we did if, else, else? This is a different way to do it where you can do switch. If a case is true, then you take those actions. So we're going to switch and look at the value of x. If x is equal to 10, you can display x equals 10. You can do a case where x is greater than y. Actually, I don't know if I can do that. Let's check if we can do that. I think the case is very specific in what you can do. So, sorry, it's been a while since I've done this. The easy way to look this up is help switch in your command line, by the way, and you'll get some examples. This might have to be very specific values. X equals y, I think. Or it might just be the value of x in there. I can't remember. Sorry guys, I'm a little rusty right now. River, with this, you don't want to do any. Oh yeah, end. Actually, you're right. We need to do an end at the end. Whew. Rusty. End at the end. So just do a very simple one. Just do with that case. Get rid of that bottom switch there. Yeah. And just try to run that.
Switch so you can
case.
put.
Yeah. Okay. That one works.
Like as ifs, as many as you want.
As many cases as you want. Yeah. You would keep going. All these cases.
They're not. You don't jump out as with an if statement. You don't stop after you mesh. It will all check all of them.
That's a good question. You know, we can check that really easily. We can change this to x equals 10, and display just here, right? Train yourself to be able to check those questions that you have. So find a way then to do this. So what he's asking is if it looks at both cases, right? Because these are the same case. And so if it goes to both or not, or if it leaves the statement. So take a look and see if it can do.
Because it would be like the difference. That's not
Yeah.
just
I guess you're
other.
you can do anything, but otherwise you can end it after that.
Or just finish it. Would it do the how do you call it? The position?
Auto tabbing? No. MATLAB does not automatically tab complete or tab indent. What you can do though is there's a smart tab thing. So if you highlight a section and then you go up to, there's a smart tab thing up in here in code. Look for it. Wrap, no, Try decrease indent, smart indent. There's a smart indent button you can use. If you click that, it'll give you, if you highlight a section of code and then click that button, it'll do smart indenting for you.
Weirdly, yeah. It just doesn't work. Yes, I put it to 10, set x to 10, and throws me out the otherwise option. What's the deal there?
Try just putting 10 in one of them. Yeah, just do 10. Instead of x equals 10.
Ah, yeah,
Just do
makes
10
sense.
to see if
10, and then here it would be y.
Try that, yeah.
But it
Yeah.
jumps out. Oh, this is like.
It does jump out, okay.
This is
These
like
are, hey guys, I'm sorry. This is supposed to just be, I think, the value that you don't have to do the logic statements in there. That's my bad. I'm trying to do more than I'm prepared for here.
So this is just a different way to write the same thing.
It's a different way to write the same thing. So basically you switch on the variable x and then you check if it's a certain value. You don't have to do the logic statements in these case statements. My apologies on this. So just do case and then the value. So then this is basically asking, is x equal to 10? Is x equal to y? And it's just doing it in different types of syntax there. And then once a case is true, it leaves afterwards. So it doesn't keep going and look at different cases. It will just depart afterwards. Remember how we do it?
I mean, the logic is a little bit weird here. If I input x equals to 11, actually it should display x is greater than
Yeah,
10.
so it can't do so. If you want to do those inequalities, you have to use if statements. These have to be just single values in here. So instead of doing x is greater than 10, you just have to put 10 in there. You can only check specific cases of occurrence, not those inequalities. That's the main difference between your if and your cases. That was my bad. I misled you there. So you'd have to take out, this would have to be just 10 here.
I see.
And so if we ran this, we wouldn't get anything, but if we made x equal to 10, we ran this, there we get
Okay.
x is greater than 10.
Oh.
Yep. Sorry for the confusion there, guys. I confuse myself all the time. But again, if you forget what this is, type help switch in your command line, and it'll come up and give you an example, and then you can use that in there. By the way, Python does not have a switch statement. Fun fact of the day.
Neither does Java.
I don't know if it does. I've never used Java before. I don't think a lot of languages have it. It's an extra feature built into MATLAB. And you can do the same thing with your if, else statements, and make that work. Okay, let's get into loops. So loops are extremely common across many different programming languages and are a main way to execute code multiple times. And River, we're going to tag you out, and Tomas is going to be leading this. And Fiona will be after Tomas. So new section here, guys, in your code. We're going to be doing for loops to start. So these are typically some of the most misunderstood and hardest to learn topics. I'll do my very best here. Stop me when you don't understand something. A for loop does an action a certain pre-specified number of times. We'll call it n times performing an action. And that action can be very complex. From there, you could store a number in an array, you could take the square root of it, you could output something, you could call another function, and it's going to do that n number of times. Okay? We're going to talk about while loops later. This is just for loops. So we'll do the most basic for loop you can do. You're going to use that keyword for, and now is when we get back into our indices again, okay? Remember our indexing through a matrix? Where we did string array 1 and it gave us the first element. We're going to do I as our index for I equals 1 to 10. And we're going to, as our actions, display I, and then end the loop. This won't make sense right now, just run it, okay? Let's get that running in the script. For I equals 1 to 10, disp I, and then end. This is a different form of logic that we're working with now. We're looping, which means we're going to do things over and over again. Okay, is that working for people? Okay. What's happening here is that MATLAB is defining a variable called I, and then the value of I is changing over and over and over. So it starts off I is equal to 1. So in the first loop, loop 1, I is equal to 1, because we told it to that. 1 to 10 is what? We talked about this earlier. 1 to 10 just gives us an array of 1, 2, 3, 4, and so forth all the way to 10. Right? Evenly spaced by 1 numbers from 1 to 10. So I is going to go from 1 to 10, so I is going to take on all these values, and it changes values at the end of the loop. So we start off, I is equal to 1, we display I. So in your command window, you should see 1 as the output at some point at the very start of your command window here. If you scroll up to the top of it, you should see 1. You scroll up to the top of the command window. So it starts off and we have 1 there. And then what happens is, so we start with 1, we go down here, we displayed and got 1 out. And then we hit the end statement, which tells the loop to go back to the top. Okay? We go back to the top of this thing, and I changes values. I becomes 2. That's the next in our array, 1 to 10. Becomes 2. So now in loop 2, I equals 2. We display I. Mike, what does this give us? 2. We go down here to the end. River, what happens next?
I would just increase to 3.
Exactly. Now we enter loop 3. I is now 3. Fiona, what's our output?
3.
You guys, these are easy. Super easy. Let's make it more advanced. Let's bring that, let's do linspace. Let's create a value called, variable called x. Linspace from 0 to 200, okay? This is going to give us evenly spaced values from 0 to 200, 100 of them. So we're going to have 100 values here. It's going to be a 1 by 100 array. So we'll have x. And I want to loop over. I want you to output every single value in x. Similar how we displayed I here. We're not going to display I anymore. We're going to use that as the index of this, right? So if we did x of 1, we'd get the first value in x, right? If we did x of 2, we get the second value of x. If we did x of 3, we get the third value in x. We can just use I as that index. So if we did x of I, when I equals 1, we get the first value of x out. When I is 2, we get the second value of x out. When I is 3, we get the third value of x out. Okay? So what we're going to do here is we're going to do display x of I. That's all. Go ahead and run that. How many numbers are we going to have outputted? Mike? Think about how many loops are we doing, first and foremost?
100.
We're doing 100, or is I only going from 1 to 10?
I is only going from 1 to 10.
That's right. So we're going to do 10 loops. On the first loop, x is 1. And we're going to display, I is 1 in the first loop. I equals 1 on the first loop. X of I becomes x of 1. Because I is 1, right? We're going to output the first term of x to the command window. How are we doing with this? Have it working yet? River, you there?
Yeah. Doing great.
Great. second loop, what value do we get out? I is 2. We're going to do x of 2, which is what we all should have the same value. What's the value we get out? The second thing to our command window? Fiona?
I have 2.02.
2.02.
Why is that? Why is it not a natural number?
Because it's the second. So what does this look like? Our x is going to look like 0 is the first term. The second term is going to be 2.02. The next term is going to be 4.04, 6.06. We're going 100 values evenly spaced between 0 and 200.
So it's 201 numbers distributed on one. Yeah.
Should be. You can check how big the matrix is up here. X is 100 numbers.
Yeah. But okay.
So x, this is here is x1, this is x2, this is x3, right? The way we index through this matrix. So all we're doing is using I to our advantage to go through and get everything. Otherwise, we have to type. If we wanted this output, we'd literally have to type x1, x2, it would be exhaustive and pointless. This is so much cleaner, and we get the advantage of this I being incremented every single loop automatically for us, and we use it as our index. This is the most common way you'll see this I being used in here. You can also use words. You can make this animal, and then make x of animal, and that would work, okay? More commonly, you use I, J, and K as your indices, but you can use whatever you want, okay? Now, what if we wanted to do it so we outputted every single value in x? How would we do that? Every value of x. Right now, we're just doing the first 10, but there's 100 values in x, right? How do we access all 100 of them?
We just change that I value, right?
Yeah, we want it to go from 1 till
100.
100. Easy. Super easy change. But let's say you change x now to be, instead of 100 evenly spaced values, 200 evenly spaced values. Now you have to go down here and you have to change this too. And guess what? You have 4 other loops that also want to use the whole thing in this. Now you have to change it in 4 different places. So what you do instead, you replace 100 by the length of x. And what's the length of x? It's literally the number of elements, those n number of elements that are in x, and now we're going to loop for n number of times. This is how you kind of generalize your code to always work. So you make your code dependent on that code that comes before it. And that way you save yourself time and prevent errors from happening and be a great programmer. Is that working for people? Tomas? Good?
Yeah.
Yep. Perfect. Love it, guys. Good. So, for loops, are we okay with that? Do we need more practice? Well, we'll do more practice for sure. But I'm seeing how this is useful here. Okay, let's add one thing here. And then Tomas, you'll be done after this. There's things, when you call things nested in programming, that means that some control flow logic is within another control flow logic thing. So in this case, let's do a nested if statement, which means that as we go over all of these values, let's do some stuff here instead of just displaying it. That's kind of boring. I want you to tell me if the value is greater than 5 or not. Okay? So what we'll do is, as we're going around each loop, we're checking all the values. We can easily get the current value. Let's just call it value equals x of I. We pull that out. So we're going to have this value pulled out. And I want to check if this value is going to be greater than 5 or not. Okay, that's what I'm curious about my data. Got all this random data here. I want to see if values are greater than 5 or not. Okay? So I'm going to come in here and I'm going to do a if statement. If value greater than 5, right? Now we have basically this little if statement here. Display whatever, yes, greater than 5, you know, whatever. And then you're going to end that if statement, and then automatically have your end at the bottom for your for. I'm just showing this little bracket here for visual, but you know, that's not a coding thing, you just do it like normal. Okay, so logically, Fiona, help me out here. How many display commands will get called?
Like how many times will
How many times will that be in our command window?
I think like 7. I haven't run the code.
7 times.
Oh,
Don't run, no. Don't run the code.
7.
Focus.
Sorry.
Focus.
193 or something.
193. How are you getting that number?
I'm not getting it. I'm thinking about based on the 100
Okay.
indices. I can tell you right now how many times it will get called. 194 times.
194.
No, 195.
Yeah,
Yeah.
a lot of times.
Yeah.
But what's happening is how many loops are we doing?
200.
200 because it's length of x. We're asking for 200 values, so we're going to do 200 loops. Every loop, we pull out a value and assign it to value, which is just the ith term. So it starts out as just x1, which is the first term. And those, right, so x is, to start, x of 0 is equal to the value, which is equal to 0 to start, right? So for 0, we come here, is 0 greater than 5? False. So we leave that, come down here, no output, go back again. X of 1, value is now 2.02 or whatever. 2.02, less is greater than 5? No, false. We leave. Come back down here, loop again. Go back through until it's greater than 5 at maybe so it's 0, 2.02, 4.04. This is going to be greater than 5, which is so 0, 1, 2. So the third one is greater than 5, and now it's going to display that for every single thing thereafter. So this is a nested if statement within a for loop. And we make sure we tab this stuff in. That's good programming practice. So this should be 1 tab in here. This is going to be 2 tabs in here. And then this is all aligned. I'm a little off my alignment here. But, right. So you tab stuff that happens kind of along the way. Right? So anything within the for gets tabbed. Anything with the if gets another tab as well. So that kind of works. Now this is because some languages, this is really important. MATLAB, it's technically not important. It won't throw an error, but it's the best way to visualize what's happening within your different control flows. Python would throw an error if you didn't do your tabbing correctly. So you make sure you tab in to do these things. Whew. Fiona, how you doing?
Good.
Good?
Well,
Good? Good review here?
Yeah.
Cool. Cool. River, how are you?
Great.
Great. Okay. Tomas, we'll tag you out when you're ready.
Yeah, ready.
Get it working there?
Yeah.
Okay. Let's do a new section. And I need Fiona at the computer. Come on up. And we're going to do while loops. So while loops, bit different. While loops have a different condition to determine the number of loops that you do. So in a for loop, you did something n times, right? We defined n by that for I equals 1 to 10, or 1 to the length of x, right? We determined how many loops we wanted to do. That's predetermined going into it. What we're looking at here. You okay? So what we do is we do a new section. So we'll do 2% signs.
I was not
Yep.
paying attention.
and then just enter after that, and then we have a new section that we can run. We can run that section with Control Enter. So in a while loop, we're going to do things, instead of n times, it's going to be until a condition is false. Until a condition is false. You can say it's going to keep looping until a condition is false. And that condition will be evaluated every single loop. And once that condition is false, it's going to exit the loop. Now, a big difference here, in for loops we had that I term that automatically incremented here. We do not have that in while loops. Okay? We have no automatic index that's happening and hanging out with us. If we want that, we have to define it. So, let me get rid of this. We don't put this in here. Let's do while x is less than y. This is our condition. Let's just do a simple display. X less than y. And then we end that loop. We need to define x and y. Actually, have to do something else here too. X is going to equal 5. Y will equal 10. You can do that in the same line if you want. And then make sure you add make sure you add line 4 to your code here. X equals x plus 1. I'll explain that in a moment. But this should run on your system, no problem.
Did you say the run command is for the section?
Control Enter. Yeah, so actually it's working correctly. But x less than y there is a conditional statement, so it'll give you 1 out, which is true. So if you want to make that, you have to add your quotes on the other side of it. Mike, is this running for you?
No.
No. Why not? Why the heck not? River, how about you?
Great.
Great? We're going to help each other out back in this corner. Fine, so might be an error elsewhere. What line is it in? So error, line 56, is it line 156? Well, it shouldn't run that. It doesn't, but errors are caught no matter what section they're in. So it's going to call it at you. You need to have a end is missing the same. At least one end is missing. So your if, you didn't end your if statements. You need to end your if statements and end your for loop. So if, and then you have, that would work here. And that should do it. Nice. Thank you. Yep. So to make sure you have is for nested stuff especially, every time you open an if, every time you do a for, every time you do a while, you have to make sure you include the end.
Would our computer crash if we didn't put the x plus 1 thing?
Yes, it would. Well, I don't know if it would crash, it would just go forever. When that crash though. So the reason why, okay, let's talk about what happens each loop here. So x equals 5, y equals 10. Is x less than y? Yes, it is. So this is true, and we enter the while loop. We display x is less than y, great, and we increment x is equal to x plus 1. So let's keep track here of loop number, and the value of x, and the value of y. Y never changes, because we're not doing anything to y, so y is always going to be 10, all the way down. X in the first loop is 5. Let's Let's go from there. So then the first loop, as we just said, will display x is less than y. Fantastic. We come down here, we go back up. But x has changed. We said x equals x plus 1, which is equivalent to saying x equals the current value of x, 5 plus 1. This will grab out the current value of whatever x is, and then store it. So it evaluates the right side first, and stores it to the left side. So x equals 5 plus 1, so x becomes 6 now. So for loop 2, x is 6. Is x less than y? Yes, it is. We continue. We display that. X is now 6 plus 1, which is 7. So x is now 7. Is x less than y? Yes, it is. What's the new value of x? 8. Is x less than y? Yep. So we keep going. It's 9. And then it becomes 10. So at one point we've got x equals 9 plus 1. So x becomes 10. We go back up. Is x less than y? Is 10 less than 10? That's false. Once this is false, we break the loop and we end.
I have a question. Just how would I, if I wanted to give out not x less than y, but like the specific numbers for each iteration, how would I type that into MATLAB? Like, give me the current value of x in this display.
You could just do x and y like that. Just ask the variable, just put the variable name in, and it'll give you that out.
And can I put it in one line, like x, and then parentheses?
Yeah, if you want to format your output, you can do that. It takes a bit of fanciness, but you can do that. You could just do display x, by the way. You could just do disp x and disp y. You could just do that, it will give you your x and y every time. If you want to make it a bit nicer, to say like x is equal to this value or something cool like that, you would want to do, probably use string cat, the function string cat. It's a new one. So we want to display a string. So let's display something we'll call outstring. And we want to construct this string. This is a completely separate topic. This is string manipulation, by the way, guys. So what you want to do is say, let's do string cat. We'll call it, sorry, save that to outstring. So we're going to define what this outstring is. Outstring equals string cat. That stands for string concatenation. When you concatenate things, you put them together side by side. So you'll do string cat, and then you'll say a string x is, and then you'll give, you have to convert x, I think that'll work. So x isn't double, right? Remember data types, x is a double. If you want to convert x to be the text characters of the value of like the text characters of 10, you have to call, it's either string, there's also might be num2 string, check that. Num2 str x, one of those will work. And then it'll put those two things side by side, save it to outstring, and then display outstring. Let's see if that works. You don't know how you're doing with that. Let's see here. Outstring, great. X is perfect. Oh, that's awesome. Nice job. So string did work. You can also do num to string as well, but that's perfect how you have it. So we're just going to run the section, so make sure you click the run section button so we don't run everything, and then display outstring. So now you get the value of x every single loop in a much nicer output. You see how we do that? Let's do the same thing for y, okay? So if you guys do that, also output what the value of y is every loop. So you have to do another. Nice, so what Fiona's doing here is that she's going to name, so she has outstring which is used for x, and then she defined outstring 1, which she's using for y. If you want to be even more clear, you could do outstring underscore x and outstring underscore y. Your choice of how you want to do your naming convention. This works perfectly well, Fiona. So if you go ahead and run that, you can see, yeah, perfect. So then you get every single time you have your x output and your y output, and you get your display of x is less than y.
But if I wanted to do it in one line, just get.
If you want to do this all in like x is blank and y is blank, you would do this all then. You would string cat, and you just keep adding more strings here. So you do string cat, keep going. This can take as many arguments as you want, and you do and y is string y. And this will give you one long line here, combining all those strings together. So this is kind of working. This is what I meant. When you can use these functions, as long as it gives you the right data type, this is like combining string x will give you, x is 8. It gives you the string now called 8 instead of the double 8. So this isn't a number anymore. It's the character 8. With 10, same thing. String of y makes the value of y that was a double into a string now. And it's just text. It's a word. The typed characters 8 and 10. This is also called typecasting. It tends to be the buzzword for it, where you take something from one and make it into another. So you can easily typecast numbers into strings and characters. You cannot easily typecast the word Fiona into a double, right? Because you can't add Fiona plus Phil to make like a number, right? You can't cast those back into doubles. How are we doing, Mike? That was a lot. That was a little string concatenation for you guys, a little typecasting all in one line. Fiona, you're good there?
Yeah.
You're rocking it right now. This is great. I mean, we'll sub you out. At this point, we'll bring Mike back up. Did that get you your output that you wanted?
This is like I guess the easiest way.
Yes, you can do that as well. Very good. Yeah, so you can do it in that one line too, and you give it, it's giving you as an answer because you haven't saved it to a variable.
Yeah, no.
So if you want to save it to a variable, then you can do that too. Best thing, I usually recommend you save stuff to variables. You could just do the string cat command, and automatically will save that to ants. If you haven't assigned it a variable, it'll just assign that to ants. But it still will give you an output to your command window.
What's giving me issue with that one? Writing it out as a whole. Like
You've got the commas and stuff in there.
No, I meant this one actually. That's probably why.
Yep. Oh, perfect. Perfect. Cool. Okay. Good job with the string concatenation there and the loops. So, oh yes, come on up. To review, for loops do something n number of times, and you define that before you get into the loop. The while loop until this condition becomes false. Okay? So, as Tomas pointed out before, if we had gotten rid of this statement here, the x incrementing, x will never change. So x will always be 5. 5 is always going to be less than 10. And this while loop would just spit this out forever. Over and over and over and over again. It could crash some computers. To get out of this, you're going to do Control C. Control C should get you out of those situations. It should stop a script in its tracks, basically. If that doesn't work, Control Delete and try to force quit something. River.
Can we do algebra with string?
Technically, okay, we'll take a side note on it. Good question. can you do algebra on a string? And I'll even include, can you do algebra on characters? So it's not algebra like adding numbers, but what you can do is use the plus operator with two strings. So if I define, go ahead and do this, let's just do another section. Let's do a string manipulation section now that we're in it. C1 equals river. Let's do C2. These are both strings, by the way, guys, so double. And then the second one should be was right. What am I doing here? So river and was right. And then suppress those outputs. And then do C1 plus C2 and run that. What do we get?
What's that section called now?
New section, you want to call it string manipulation. There's a lot more you can do with strings, but since MATLAB is mainly out here just to be doing math, we're not going to go into a bunch of it, but since River brought it up, we'll take a look. C1 plus C2, what do we get? Go ahead and give that a run. River was right. Different than mathematical addition and subtraction, right? But the operator recognizes you're trying to use this for two strings. You can do it. The same thing is done with string cat, C1, C2. The benefit of string cat is that you could add a bunch more strings here and combine them. You also probably could keep adding stuff here too. There's always more than one way to do things in any programming language. String cat. Okay, let's save, okay, keep this and let's just add on to it. Let's save this as C3 equals C1 plus C2. And then do the first index of C3. Output that. See what that gives us. I'm curious actually. It's been a bit. I gotta learn sometimes. C3, 1. You usually want to put that 1 right next, the parenthesis next to the 3. So really scoot those together. Yeah, get rid of that space in between. Yep. Go ahead and run that. So the whole thing is stored as one thing there. Okay, and then do whos in the command line. Go ahead and do whos. Go to your command line and just type whos so we can see those outputs. And we can see that C3 is a 1 by 1 string there. Okay, I want to try something. Let's do C4 equals string cat C1, C2. And then I want to see the first element of C4. Yeah, we're doing that. So C3 is made using the addition operator. C4 is made with string cat.
That's all the same output.
But how about we use num2 string 10 plus num2 string 9? It's different, it's a matrix.
And you're talking in string cat? Or before in the while loop?
If we input num2 string
Num2 string?
10 plus num2 string 9,
Mm-hmm.
it will come out a matrix.
A matrix, yeah?
Yeah.
So, that's exactly. So here, oh, it still gives us just 1, really? That's weird. But, string cat, I thought string cat would have given us, it's a bummer. Still gives us as a 1 item. What I'm trying to get at is if you do a matrix, like what River's saying, you do
Num2 string.
yeah, so if you're doing num2 string within your string cat, like that, it stores them as separate, makes a matrix of your first string and your second string. Right. Instead of just making it one blob term, like one long River was right, which is what we're getting right now. We're getting River was right. as opposed to river was right. Very subtle difference between these two things. It's just that this has one term, this has two terms. So it looks like the number string allowed us to get those two terms. That's only if we're doing like 10 in here and stuff. I was hoping string cat would give us the second one, but it looks like it just makes it into one big one. But neither here nor there, not a big deal. Okay, that's string manipulation. You can do similar stuff if you did this as single. Just do that really quickly. Make those into single apostrophes now. It's going to give you a very different answer. I think string cat should still work, even though we're dealing with characters now. Right? These are going to be characters. If we just use a single thing, these are characters instead of strings. And if we do the first, what do we get? It should just give us an R. Otherwise I'm crazy and you guys should leave. I'm hoping that's what happens. So you gotta change these to singles up top. Lines 209 and 210 there should be single instead of the double. So just do apostrophes instead of quotes.
Yep.
And that changes the data type. And if you just run that. Incompatible sizes, so we can't use arrays of incompatible. That's for the which command? So line 211. So we can't even add those together. Interesting. So you can tell it matters what data type your stuff is. I don't do string manipulation a lot, admittedly.
Okay, characters don't want to be added.
Yeah.
But yeah, checking just what C11 is.
But yeah, so instead of adding them, you can just take a look. Try doing just a string cat command. So try getting rid of the C1, C2 thing. Try just doing string cat and see if that works. String cat works? Okay, oh, yeah, get rid of C3 there. Forget that. It's a matrix?
Yeah.
Ooh. So let's do who's in your command window. So it's a 1 by 14 characters, 1 by 5, 1 by 9, right? So now these are matrices of, this is a 1 by 5, this is a 1 by 9, something like that. Because each of these, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all independent characters, and there's 9 of them together in a 1 by 9 array of characters. And if we add them together here, it just makes it into one fat one that now has all these characters, but it's 5 and a 9, so this gives us a 1 by 14. And if we just ask for the first thing out of it, R will be the first thing out because it's C1 first and then C2. Interesting. Not crucial for MATLAB, but good to know. Okay. Let's figure out if a number is prime or not. So given a number n, I want you to figure out if it is prime. Let me know what you guys think. We're going to talk through this one, but you guys are going to write this. Alright? No more help from me right now. I'll answer questions, but giving it. So firstly, no, you guys have figured it out. I'm done. Ask me questions. What would you want to figure out first? Fiona, how do you even figure out numbers prime?
It's not divisible by any number greater than 1, right?
Correct.
I mean,
Very good. Very good.
it's a lot of numbers.
That's a lot of numbers. How many specifically? How many numbers do you need to check? If n is 70.
Are you taking, I guess every number that's greater than 69. technically.
Okay.
Or 60.
You're right there. You're right there. Come on.
Like if it's divisible by any number between 1 and 69,
Mm-hmm.
except for 1,
Mm-hmm.
then it is prime. Like if the result is a natural number as well.
You're saying we should do something for 2 to 69. Is that what you're
Yeah.
saying? Okay.
2 to n minus 1.
Perfect. Okay. And if you want to do stuff multiple times, what do you use?
The for loop.
For loop. Perfect. Okay. All right. This is good. We're getting there.
How do you check if the number is natural?
Well, there's no check for that. You can't check if it's prime or not. You're talking natural?
Yeah, like
Natural number?
if something is divisible,
Does that make it a natural number? Is that what that is?
the result must be a natural number.
You want to check the result. So the result of the division?
Yeah.
Okay, you think there might be a function for that MATLAB maybe has?
Is there a function to turn the result of something into an integer and back?
Maybe. Break it down into parts. So you want to check, you can do division, right? Division's easy. And you could look at the remainder of division. You can also Google this. I will not be sad. Oh. And there's 2 parts. There's the side of like, how would you, as just a human, if you had a calculator, figure out if something's prime or not? And then there's making it into code, right? There's 2 sides of this problem. So make sure you figure out the first side of how would you legitimately check if a number is prime. And once you know that, you need to write your for loop for it. There's 2 sides of this problem. Mike, what are you thinking? What are you thinking?
I'm looking at the for loop section we did earlier. That's what I'm thinking.
Okay.
Like if this works, if you can, this is the division, then should be, like if you turn a number into an integer, it gets rid of the things behind the comma, then turning it back into a double makes it, you can compute it with this, but I don't know if that stuff works.
Does your loop work? Did you try? Does it work?
Well, 1 second, I'll just try it out.
You guys can work together on this. Team effort here.
So I think I have an idea what the algorithm might be.
You want to put it on the board? Right on the board so people can...
On this?
Yeah.
I will try to actually does it.
Okay, it's okay if it doesn't work yet. You know, you can all work together to figure this out. So we got an n defined. That's a good start. We want to check over numbers. We talked about that earlier. We said from 2 till n minus 1. Just want you to get a for loop set up there. Like,
I'm looking at this like I look at restaurant menus currently, which is that nothing is standing out to
I
me.
mean, it's kind of like
So
this is the good logic part of coding. So
I assume we have to have some output that gives us the numbers from an n that we can manipulate.
Okay.
Right.
Yeah, you wanna,
So we need like the data to work with.
okay,
So
how
we
would
know
you
we
get the
have-
data to work with? We've defined matrices before, right?
Yes.
Yeah, but this works, I think.
Okay, why don't you go to the
Let
board
me-
and
let me
talk
tr-
through.
let me try to put a 71 as a prime number, right?
Yeah, that should be good.
Then it doesn't put out anything, so then okay. So it can just like but I have to kind of put it in the computer context.
Just right up there.
So we got n is 70, and we just take that over, and we get to iterate from I is 2 to 69, which is just to have that flexible as n minus 1.
Mm-hmm.
And then it's like the check if it's prime. So if something is prime, then dividing n by I gives a natural number, and that's the question. You put this in parentheses, but so
yeah.
If n divided by 1 is a natural number, is the question that you have to ask. And yeah, the idea I had to check if something's a natural number is like this is a double. And I mean something I guess you gotta know, but like you can get rid of anything behind the comma of a double by turning it into an integer. So there's like int commands of different sizes to turn this stuff into an integer. I just found that in there.
Yeah.
So if you put n divided by I into there.
So like in the first loop you'd be doing 70 divided by 2, correct?
Yeah, 70
Okay.
divided by 2. And then this would be just 35.
35, okay.
Yeah, so 35. And like this is not an elegant way
Yeah.
to do that, but like
Okay.
to make I guess to make these things computable with each other, you have to turn that back into a double, which you can do by just putting that around it. And if that's equal to, like if you take that off of here and if that's equal to 0, so double equal, like we check for equal, then you can just print out like what is that display, like whatever it's prime, right? And then and both basically.
Okay.
And then it will, like if it's not prime for a number of reasons, it will just put that out multiple times. So for 70 it did that like a bunch of times. So like there's 6 times in this iteration that it shows that it's prime. It's not prime.
Prime or not prime?
It's not prime. You gotta do it's not prime.
It's not prime in that case.
Not prime, yeah, of course.
Yep.
This shows like it's not prime. So it's not prime. But like if you put an else in here, that would be like if you put an else in here, you would always get one of these answers. So probably putting a Boolean with that and changing it here and then putting an end result would be like the cool way to do it.
Would be the cool way.
But
I shall hang out to the cool way.
yeah.
The coolest way is when it works.
Yeah, this works.
Okay, so do you try with a prime number?
Yeah. Like-
71, does it give you no output?
Yeah, if I put 71, it doesn't give an output.
Alright. Alright, okay. So, this is, of course, again, there's a bunch of ways to do this, but Tomas was able to do it. So, this is probably confusing, this whole notation over here, to some folks, so let's go through what that looks like. So he's saying, so let's do for the second loop when n equals 3. So when n equals 3, we're doing 70 divided by 3, which is what? You guys do that in your command window for me really quickly? That's like 27 something, 28.
Yeah.
You can plug it in your command window.
It's 23.
23?
It's not a whole number, it's 23.3.
23.3, alright. So we've got 23.3, and then he's subtracting, so n over 1 is still 70 over 3. Right, so if we're doing a double int 23.3, right? This is what's happening over here. So 23.3 as an integer, integers are only integer numbers, so whole numbers greater than 0. You could also just have rounded this if you wanted to. You can just round it to the nearest number by using the round function.
Okay.
So you could round the number. But what he's getting at, though, is he basically converts this then, making an integer makes it 23, and then a double makes it the same data type. Probably also MATLAB's forgiving, probably would have let you just do an integer. Double minus an integer probably would have worked. MATLAB's not that specific. But this is giving him out 23. That's important because he's noting then, 23.3 minus that, he has some extra tangible value. This gives you, 0.3 out. So that's 0.3 is what this part evaluates to. Then he's saying, is 0.3 equal to 0? In that case, no. So this is false, so it evaluates to 0. And then he doesn't run this because it's not prime in that case. No, that's if evaluates to 0. Yeah, so this part isn't run.
I guess if you
Because this number didn't go in evenly into 70.
I guess if you leave out the double, it turns the first number into an integer. So then it doesn't work.
So it's
Then it doesn't work, then it will always
okay. So you have to come back. Okay. Yeah. You could just I think rounding this would be probably a better way. So the thing is, if you do something like so when n is 10, this is where it will output. We'll do one that outputs this. So when n would be 10, for example, he's doing 10 minus this whole thing. This just gives out 10, so 10 minus 10 is 0. So does 0 equals 0? Yes. That's true. When that's true, it prints out it's not prime. Because we just found something that divides evenly into 70. So in that case, it's not prime. Make sense? One way to do it. Did anyone else do it a different way? Did you end up getting it?
Did it similarly, except I used the modulus.
Use the modulus command. What is the modulus command?
Just mod.
Mod?
And then the number, it's the first number, whatever the first number you want input divided by the second number. So it would be like, I did 70 or n, and then I, which I also defined, I think, the same.
Yes, it's a very similar approach as well. You take the modulus, which gives you the remainder of a division. So similarly, so if we did 70 divided by 3 or whatever, it was 23, which gets us to 69. So this would, so mod of 70 comma 3 would give us the value of 1 out. And if there is a value that comes out, that means it didn't go in evenly. And that way you know that that specific one we checked, 3, was not an even divisor into it. So if you did 70 and 10, mod 70, 10, you get 0 out because there's no remainder. In that case, you know that there's a 0 here, that number is not going to be prime in that case. So you're checking those logic things. It's a bit tricky. River, you said you got it as well, correct?
Yeah, but the problem of that that code is that if you prime, in that position, if you run the code, it will print out a lot of it is not a prime.
Yeah.
A bunch of
Correct.
it. So the solution I gave for this is I just use another if condition. I use a variable value equal to I, and then I use another condition if value larger than 1, then display n is not a prime. Else
Nice.
display n is a prime.
Very good.
So like you put a boolean and check after.
Yeah. So that it will be only display once.
Very good. That's exactly it. 'Cause really, once you know it's not prime, what you can do, and teach you guys this yet, there's a lot that goes in these languages. You can also add the command break, which breaks out of the nearest loop. So that way, once you know it's not prime, there's no point in going over all the rest of the numbers. You can just break out of that, and you're done. Little pro tip. So once you, so similar. What basically you did exactly what the break statement does, River. You added another thing in here. You checked if that was a certain value, and then if so, you were done. You ended the loop. Same idea. So yeah, a lot challenging. Mike, you're good to retire here.
Oh yeah.
I know.
Yep.
We're getting glazed over, guys. We got about a half hour left. Whew. Let's see what's next on our agenda here. You guys want me to show you how I would do it really quick? I can show you. So if n equals 70, what I would do is, all right, so for I equals 2 to, n minus 1, same thing here. And then I'll probably define
The round, by the way, works as well.
The round does work, perfect. So I'd say is prime. I'd start assuming that it wasn't prime, so I'd define a Boolean is prime equals 0, and then we'd say, okay, so in this 4, we're going to go through I is 1 to n. We'd do the modulus, as you mentioned there. So mod, I'm going to save that value, val, I call it remainder. Remainder equals mod of n and I, which is exactly, I think, what you were saying. So our methods are pretty much the same way. So that would be the case there, and then if remainder did not equal, what is this? If remainder is greater than 0, it's hard. My brain's lacking here right now too. We want to check something and I want to say, so if it is divisible and not prime. So if the remainder were to be, let's just say, greater than 0. So if it was like 1, that means, okay, that means it's still a prime number though. So we want to check if it's equal to 0. How did you do this again, Fiona? What did you? I'm struggling right now a little bit.
Equal to 0, then
Well, it's equal to 0.
and then I added it to like a array of factors so that
Oh, so you could go back and have those.
yeah, and then I checked if factors was greater than or equal to 2. Then
Equals 0.
She went out of the loop and then took the second if.
Yeah, there's a good way to get out. I wrote this in Python the other day. Now we're getting a little brain dead right now. I'm with you guys.
It's prime. It's not prime. And then check it.
If is prime is larger than 0.
This is my Python code to do it. This works really much better.
It's larger
Oh no,
than
different
0.
Python
Yeah.
code. Hold on.
Prime is
Here.
1.
So I did this double thing here. Basically,
Oh,
yeah, you're looping over from 2 to that number if this is the modulus operator. If the modulus is equal to 0, the number is not prime.
But you put it here, yeah, after
So if the remainder is 0, that means that something evenly went into it, so it's not prime. And so I just returned a 0 at that point. I ended the function, returned 0. That's only a Python thing. What we're talking about is breaking. We just do a break statement here and we get out of this loop. And then otherwise, if we never had that, I had just to return the value of 1. So this would just be this is the Boolean they're talking about right now.
Oh, yeah.
And then I was just coming over here and getting some outputs. This probably doesn't help that much. It's a different language. But the logic
way better.
is built in
So
there.
much more code.
So. Okay, a tough example.
I don't hit break if I do this way.
I need some code in here though for the people that aren't here.
I just put
Wait a second, guys.
Can you run it and then just save the result?
So this should be, it's not prime.
So if mod of n equals 0, not prime. Not prime.
Equal. It's a comparison.
Not prime.
Yeah, correct.
Is prime
That was right.
equals 0.
Okay.
And then want to do.
Yeah, cool.
You guys got it working?
Yeah.
Yeah, we did the round combined with the
With the Boolean in there? That's what I'm trying to do with my brain, but it is not firing. Is prime equals 0. Otherwise, so if. And then we just basically, if we don't set is prime equals 0, we want to do is prime equal to 1 at the end here. So we assume it's prime until we get something is prime.
And you don't need
equal to 1.
then you don't need the second is prime down there.
That's correct, yeah, wouldn't need that. So if it is prime, let's see if this works. N equals 70 is prime is set to 0. So then what should be done here is so then if is prime equals 0, 0, we should display string cat n. So we take n and put it into this thing, and we say n is not prime. Else we should display string cat n is prime. Right, so that way you kind of have like a nice.
Does the string cat
I think it has to be. Sorry, this needs another. I think round of. No, I messed up my string cat. It should be string cat num to string n like that. Num to string n. There we go. Whew. You guys were questioning my abilities there for a second. Rightfully so. So there we get 70 is not prime. And then if we do a true test, let's do 71. 71 is prime. So we're checking every value of n going up to n. If we go evenly into something, we get 0 out, and we know it's not prime, so we set is prime equal to 0 for false. That's all we're doing in our for loop, and then if we get out and is prime is still 1, we're okay. That's probably the cleanest, one of the cleanest ways to do it. But any way that works for a new programmer is the way that works. I would not be concerned at all if you can't get that to happen. Okay. I'm going to talk about structures really quickly, and I'm going to talk about multiple files when you're dealing with functions, right? So ideally, actually let's talk about multiple functions because we just did this. This shouldn't be in your main script. What we should do right now is make a function that returns 0 or 1 based upon this information, right? You don't want this to just be clogging up 20 lines of code for what you're trying to do here. So I'm going to show you how to make this into a separate .m file, a function file, that we can call for any given number in our script and use it. Take a look. So let's firstly open up our, make sure our layout is viewing our current file. So I'm in here. So I've got access to all of these files. We need to make sure that we create our function in the same spot. This is where we create a user-defined function. Go up to New, and then Function. Okay? A function is just, you can also do it as a script, but a function gives you some automatic features here. It's going to open up a brand new thing here, and it's got a bunch of nice inputs and outputs already for us. So a function needs outputs, and it needs inputs. It also needs a function name. Let's call this isItPrime. Okay? That way, we know it's going to give us a Boolean. It's going to give it a yes or no out. You want to make your functions verbs typically, so calculate something or do something, and you want to make sure that your variables are nouns of things, okay? Functions should be verbs. So isItPrime is our function name. Our input is going to be what?
So can you quickly repeat, where is the function heading?
This is the function name right here.
Yeah, where can I add the function? Where is it?
You go up to New.
New.
You can do either a script or a function. So we've got isItPrime. What's the input that we want to this function? Just a generic number n, right? So like we did 70, but we're going to change that in our code to be 100 or 80 or whatever. So let's just call this n, capital or lowercase, whatever you want to do. That'll be our input. We don't need this extra text for now. And we have to use our inputs to get an output. And what's our output going to be? It's that Boolean, so it's going to be isPrime. Okay? Kind of like what we had before in our main script. I'm just going to call isPrime is my output. So I'm going to take n, and then I'm going to produce isPrime in this function. To do that, let's bring in some logic like we had before. So I'm going to go back to our crash course script, grab this stuff back, because I need it now. So we're going to set isPrime to 1 to start, and then bring in this stuff. N is going to be capital in this case. So I'm going to do the same stuff I did in the main script now, right? I'm going to go for I equals 2 to n minus 1, do the modulus stuff, blah, blah, blah. I'm not going to do any sort of outputs right now. I'm just going to do isPrime and just give back isPrime. Technically, this should be indented. Editor. Smart indent. I want it to be indented. Okay, that's fine. When you save this file, you need to save it as the function name. So in this case, it's isItPrime.m. Same capitals and everything. Save that in the same folder as your other script. Okay. So this function, what it does is it takes in some generic value n that we give it, and the way we use this is by calling isItPrime in our main script, and we'll do that in a second. So we're going to call isItPrime and give it a number like n. Set isItPrime to 1, set isPrime to 1, go through and do the loop. We might set isPrime to 0 if it's not prime, otherwise isPrime is 1. And MATLAB is automatically going to return this isPrime value. Because we created it, and it exists here. Whatever the value is, it sends it back to our main script. So if we go back to our main script, we can get rid of all of this portion here. Hold on. Get rid of this. And we can call isPrime, isItPrime, and pass n in, just like that.
Can you open the function again? Okay.
So now when we call it from the main script, there we go. We get this is what we get out right here. Is this isPrime value is assigned either 0 or a 1 from our script. Now these inputs and outputs don't have to have the same name. For example, you could do, this could be num here, num. Make sure that in this local scope it works. You can just call this output.
So you can think of this as like chunks. So if you're writing code and you've written specific pieces that you use for different things,
Yep.
it's all in the same general file location, so you can just put in the function you created. It accesses this piece of code that's not part of your current.
100%. 100%. And then this can be output. So this way you can use it multiple times too. You can pop this in and out for, you want to use it like 70 lines later in your code. You don't have to bring in a whole other for loop to do it. You can just call is it prime. Make it really easy to do. You could do a function to calculate a specific error you want to do, and it takes in 2 vectors, and then calculates the error and returns the error. You know, there's a lot of stuff you can do here. So just make sure that when you have your inputs that your naming is consistent, and then your outputs, you've got your naming consistent. If you want to make it fancier and give you the output, you could make it display, right? You could bring in that logic here. You could bring in this, plop it right there, and have it display this whole stuff here too. So if output, you can just display that stuff. This needs to be num to agree. And now this function will give us a display output. So I can just call is it prime, and it gives me 71 is prime, and sets is prime to 1. You can have functions that don't even give you outputs if you want. You can just get rid of this output. You don't need that at all. And then run it. I think this should work. Now you have to do one thing there, okay. Ugh. Output. You can make it, you can just make it, what you do is just this. You could just do is it prime. It still gives you the answer of 1. There is a way to make it void though, where you give no output, I think. I think you just do set to null, whatever. That's where how you have your function, right? So now any folders that you have, if you have a main script and another file as well, you can use those .m files to just pop in and out. And those .m files receive copies of the variables. So if this is how it relates to scope. So I'm passing n to a function, right? Right here, I'm saying is it prime n. So MATLAB creates a copy of n, takes the value of 71, passes it to a function. That function receives that value, does work with it, and gives you an output. That value is never changed though, okay? N is never changed in the main script. N will always remain 71 afterwards, okay? So even if you went into that is it prime and you put in there that n is going to equal n plus 1 at the end, doesn't matter. It's not going to do anything to the n here. So this is called a pass by value operation. You pass a copy of it to the function. Pass by value. Other languages do other weird stuff where you can change those things. MATLAB tends to take up more memory by making copies of stuff. But you can imagine if you had a 5,000 by 5,000 matrix, copying that would be pretty intensive. So other languages allow you to pass just a reference to that, and not what you can do, but it's different than a copy. MATLAB does full copies of stuff. Come on.
Something, yeah, just something in my code doesn't work. I'm not sure what it is, but it might be like a concept.
Just undefined function check prime. So where are your functions stored? Are they all in the same file? Intermediate is there.
In the same folder at least.
Okay, how about the cases of them? Check prime, lowercase, check prime, good. When you call it, where do you call the function? Check prime of k equals 7. You need to go into the crash course folder. You're just viewing it, double click that.
Yeah.
We'll try to, there you go.
No, it should
You have to go try it again. You have to be in the physical folder. You can't be looking at the folder. For example, I can't be looking at my desktop folder. If I go out one level here, even though all my files are in my desktop, if I try to run this now, well, typically it gives you an error. I added that to my path earlier.
No, it works.
But yeah, see, so now it works. So
Yeah, there's two schools of thoughts here. There's like the organized brain, and then there's the like grad school brain. My friend Kristen has a community MATLAB folder that she throws everything in.
oh God.
and it's huge, and she tried to give me the same thing. I was like, no, the lab stuff is in its own folder,
Yeah.
because there's no way I'm gonna be able to find the one file.
Crazy.
But
Crazy
but,
stuff.
Yeah, there are people who just function in one, our users too, they have like one R folder and they just slam everything in there.
It's like people with a desktop full of stuff.
Yeah. I recommend doing one folder for a given related project, and then have a main script in there like this, like the MATLAB crash course.m or whatever your main, like what the project is. And then what should be done is throughout that main script should just be a bunch of calls to other functions. Right? You shouldn't have any like big for loop, unless you have like one main for loop in your main script. But really your main script should call function 1 and give you an answer back. And then you should be using that answer to get you, you're going to call function 2, and you're going to use x into that and get y out. And then eventually you're going to display the important answers at the very end of your script. But these are calling other .m files that do the important stuff that you want to be doing. Right, so you're passing, right, so you pass a copy of A over here, and it gives you back X. You pass over a copy of X to here, and it gives you back Y. Then you display Y. Right, your main script should be a series of function calls, and all the actual work being done should be in separate files. That's when you get better. If you just have like a 100-line script, that's not a big deal. Once you start doing really complex things, that these get really complex, you don't want your main script to be thousands of lines long. No one's gonna have the time to read that. And if you have good names for these things, it should be very simple to see like, oh, here I just had to normalize my data. That was A. A is my raw data. I made a function that normalized it the way our lab formalizes data. And then I calculated the stats that I like to see from my data that always are used. And that way you can use this over and over and over. And these names have to change, of course, to normalize and to calc whatever you're doing. Right? And then at the end of the day, you're just displaying your stuff that you actually need to see in the output. So that's kind of how you want to make sure you organize things as you get more advanced into your programs and whatever applications you're working on. Set them up like this, and you'll be off to the races. Come on.
I have one thing that maybe we can cover quickly.
Yeah.
Because I think it's important both for what I want to learn and for the machine learning. It's like having a CSV file, like an Excel file.
Sure.
How do we import it to be an array in here?
Yeah.
Is that something we
can do that, yeah. I will also plug again YouTube channel. There's a good video on just that. I also have one where I import a CSV file, take all of the columns, make a scatter plot out of it, so you can easily visualize stuff
yeah,
too.
then I will check it out there.
So that's, yeah. But basically, I'll just tell you, just so you kind of know what to look for. You're going to use, I think it's XLS read or something like this. The file extension read, and then the file name, but I think you can do a .csv in here. Something like that. And then when it brings it in, you end up with a big, I think they call it a table of information, right? You'll have your headers of your Excel file up here, and then the data in it. And then from there, you want to be able to extract that information. And I think you have to call it, you have to do some sort of like table to array function that converts. You'll call out this right here by doing you'll call this data when you import. So data equals this, which is essentially whatever your data is. And you'll call it data, and you'll call all the rows in the first column. Let's actually talk about this. When we were doing, we had arrays that were like 2 by 2 or whatever. You had values in there. This was a 2 by 2 matrix. And if you wanted to index through to get this term, it was going to be the second row first column, right? 2, 1 to get this value. If you want to get an entire section like that, an entire column, you're going to say, I want all the want this is all the columns in the second row, so you do 2 colon. Second row, all the columns. Okay, so in this case, I'm doing data. I'm saying I want all the rows of the first column. If you wanted the 4th column, you do all the rows, 4th column, like that. So you convert that into this, and you do whatever this is, like your strain matrix or whatever data you end up getting. That's in it. So this is strain here, and you have position x, position whatever your data is, right? You then do strain, table to array, get that stuff into here. This is for this. Yeah, that's basically how you'd be doing it, something like that. And then the output stuff, also super simple. I don't think I have a video on that though. But if you look up how to output stuff to a CSV, you'll basically be taking these variables in your workspace, and I think it's just called save. And you do a command that's like save and then the name of the file. Save it as a TXT or a CSV or something like that. And it just saves your workspace variables to a TXT file. You can do probably a CSV like that too. So straightforward stuff. Cool. But yeah, the important thing is to get it in and then get it to the data type that you want. Right, it also might have these all as, right, it might bring these in as strings, for example, even if they're numbers. And it still might bring them in as strings for whatever reason. So you want to then convert them and do, cast it as a double. So do double on strain. And then just save it back to strain. Right, so that way now it was a string, you call double on it, so you went from a string to double. Now you just overwrit the variable, so now you have strain as an array of doubles. Stuff like that.
Perfect. Yeah.
That's super useful on big data files. I've been cheating and I just format my Excel docs beforehand.
Also good to do though.
But if it's massive, Excel's not. It's like CPU hungry. If you try to do we have data that's even a month long, 10 different variables that's collected every 15 minutes. And you try to take out zeros and stuff, Excel goes,
yeah, it's gonna go crazy.
This is just because it might be like characters inside.
Yeah, you might. It depends. Usually MATLAB is pretty good about recognizing that. But if you wanted to cast it in a different type, you could go ahead and do that. Yeah, I mean, and it's also garbage in, garbage out, right? If you import some data that's complete trash, I mean, good luck trying to do stuff. If you do a little bit of pre-processing that helps it, R, MATLAB, they can do some more formatting. I think R is better at handling data and formatting it well. MATLAB can do stuff. You might want to look up maybe a series on data formatting in MATLAB that might have some more functions that'll be we obviously didn't do that specifically today.
we did learn it in R, but sometimes because that's all Excel docs is what we use generally.
Yeah.
Sometimes we just move the columns around and I take the pieces out so I can minimize my coding burden.
That's exactly.
Not that good at it, honestly.
No, it's tough. It takes a while, so it's all right. But general idea, all that goodness.
Yeah, I was looking at classes on main campus. And there's no coding classes unless you're in that vein, and they're very specific and they have prereqs. It's like, okay, well, I just wanted a general. It's kind of weird. Like in my undergrad, they didn't emphasize coding at all. And I got to grad school and they're like, oh, do you know how to use MATLAB? And I was like, and they're like, what about R?
No, it's
hard. You're going to need to learn how to do that. Great.
Man, yeah, it is a lot. There's a lot of good. So MATLAB produces its own set of tutorials. It's called the on-ramp. I think it's fine. I made my own. I think it's better. It's a 2-hour thing. That would, a lot of stuff probably there.
I know there's videos out there about it.
There's good videos out there, and in my opinion, you need to watch many different authors or creators, right? Because they're all going to come at it from a little different perspective, and getting the same content multiple times from different perspectives will give you that well-roundedness, right? It's the curse of knowledge. Like once you know something, it's hard to know what it was like before you knew that. So that's why it's hard to teach. That's why teachers suck. You have these PhDs out there that are trying to teach you MATLAB. It's like even me. Like there's stuff that I assume that you guys know that I'm like, oh wow, we have to go over that longer. It's a difficult thing to approach. And I think coding has a big gap when you're trying to get back into what it was like before knowing this stuff. Hope we bridged some of that today, but you know, my channel's great, I think. I wouldn't keep doing it if it wasn't. But there's also other great channels out there that'll give you different perspectives on the content that you should take advantage of. MATLAB itself puts out videos, there's other creators out there. Do that stuff. Do the, there's online certifications in R and stuff like that. That's how I did mine through DataCamp. I did R through them. I hated it because I was resisting absorbing it all and stuff.
Yeah,
And
but
that,
they do a lot of like very math-based with data sets that are already in there, and when you have original data sets,
it's so different.
Functions don't really work.
Yeah.
Yeah.
Yeah, it's hard because they can't do it for your data set, because your data set's going to be so different than everyone else's. So they can use these pre-made data sets, but then it doesn't feel like your problem. So it's a challenge. But
yeah. And once I write code, I realize that I go back into it and I go, what the hell did I do here? And I refigure it back out, but I can't like virgin write anything.
And then it takes, again, I've been doing this now for like 6 years, and I feel pretty good, but it's taking me like learning a little bit of Python. I know C++ now. Like it takes going around the block a number of times and doing stuff like this a number of times and watching the same videos over a number of times, and you know, it's something we forget. You know, we did undergrad for 4 years on a single topic and we got good at it. Then we also had to learn coding in about a month. Right? It's tough. Like, we need to, right? We're in that time crunch of like, shit, you have to do it for your thesis, right? Your master's thesis has to be in MATLAB. It's like, whew, you know, you gotta really grind into this.
I took Gambino's class, his ecostats class,
Yeah,
because it forced you to learn R and statistics at the same time, and I was like,
yeah.
And I ran my data in that class.
Wow.
I refused to take any other data that we were using. I was like, nope, we'll run the data from my experiment.
Good.
And when I was done, for year one data was analyzed. It was great.
That's awesome.
Thank you so much. I feel well more comfortable
Good.
looking at MATLAB.
Yeah. I hope you can feel alright. Remember, knowing your data types is big for anything you do, and how to organize stuff. We didn't cover structures. 5 minutes. Structures. Because these are very powerful. I wouldn't tell you them otherwise. So we talked about matrices and arrays, right? And those can hold any data type together in a matrix format, right? So you can do strings, you can do characters, you can do doubles. But you can only do one type of variable in a matrix, okay? So if you make a matrix, it's going to look like, you could do just Booleans, right? Or you could do characters, like that. You can't do a mix. You can't do right. You can't do this. You can't have a string and then a Boolean, right? Or a double and then something. It has to be all the same data type. What structs do is they say, screw that. Let's just store these things totally separately, but also together in the same thing. So what they'll do is they'll create, let's just call it like a robot, and then they do attributes. So you'll do robot.x, robot.y, robot.name, robot.age. And all these dots are going to be different attributes of this robot. So you can still store things in here like your Boolean array or whatever, but you can also store in here the name of the robot, the name of, is it on or not, a Boolean there. You can store the age of the robot there, the double, and all this stuff is contained in one object called a robot. So if you wanted to assign this, if you wanted to create this, you just you do robot.x equals 1, 0, 0, 1, like that. And then you do robot.y equals, I didn't assign that, but 9 and 7.
Do you do the rectangular brackets?
Yes.
When you type it in?
These are square brackets, yeah.
Square brackets.
Well, so because what is this? This right here is just a typical matrix, right? You could do A equals, and then robot.x equals A. Right? You're just assigning a matrix into this attribute called x of a robot structure. So robot can now hold all these different things together, and then you have this robot object that moves along, because these are related to the robot, right? They're specific attributes. It's like if we did this for human. You know, we've got name, we've got ages, we've got hobbies, we've got interests, we've got height, we've got weight, all these things that belong to us, and you can store them in their own little compartments. So you can store different data types in the same struct. This is kind of getting close to what's called object-oriented code, where these things are a bit more advanced than this, but it's this notion of having these objects that you can use for things. The cool part and the main advantage of these, it's nice for organization, but when you call functions, like if I wanted to calculate the distance between two robots as a function, I could include robot 1 and robot 2, right? Assuming this is robot 1, robot 1, robot 1, right? I could pass in 2 robots to this function. If I didn't do structs to calculate the distance between these 2 robots, I'd have to do dist2 robots, and then I would have had to make variables for all these. So I would have had to do like robot 1 x, robot 1 underscore y, robot 1, right? I have to have separate values for each of these things. I have to pass all those to this function, and it becomes super cumbersome. And then do all that for robot 2 x and robot 2 y, and so forth. Super painful if I want to calculate stuff that just relates to the 2 robots.
So you can write a function to access whatever is behind the first word, and then x.
Exactly. You just do this. So in the function then, in your dist,
you write like y.x.
Exactly. So in your dist2 robots function, you would call it a and b are the robots coming in, and you just, if you wanted to use these things, you do robot, or this would be a, because I call the input a. I call a.x, b.x, and you access those members that you defined of your structure that way. And that's also nice too. So if you change what's in your robot, so if I added a dot interest, and I had some interest like hiking, right? I don't need to change this call because it's still included in robot, and I'm passing robot. But here, if I wanted to use this interest in the function now, I have to come over here and add another thing, robot 1, I call it interest, and robot 2, right? All these different arguments, you keep adding on to that, which is just ridiculous. So if you're doing, yes, River?
So what you mean is to keep the same structure, but change the different variables.
You're changing how they're organized and held together. Yep. So these are still, this is still an array, which we did before. Still an array, just a string, another string, a Boolean, right? All the different data types we've been talking about. Before we were making these individual variables, right?
Can it distinguish between, like if you put a 0 if it's a Boolean or a...
Technically you want to put this as false.
And false it can...
False, it'll call it a 0 logical. Before we were having to do robot 1 underscore x, robot 1 underscore y. We had to make these all separate variables, right? What I'm saying is we can now include it. You still do the same number of calls, but then you just have it all together in this robot structure. But then moved together. You can update it. Do more things. So like I did an AUV simulation, underwater autonomous vehicle, and we just used one AUV object, and every function we used, we had to like update accelerations and update position and calculate a distance to something. We just passed the AUV object in. Super easy. So when we were adding tons of stuff to this AUV, we had these hydrodynamic properties, we had surfaces, we had length, we had distance, we had weight, buoyancy, all these things that we were just adding in. All our functions would still run, because all we did was just call AUV in these functions, and then we had access in those functions to everything that was in the AUV. Super nice. And then each of these functions returned the AUV back to us. So we make changes to it, return it back, and then we get the AUV updated. That's another strategy to use. So like if you bring your data in, it's kind of what R kind of does a little bit, right? You have your robot $1 $X, robot $1 $Y, so you're getting your columns of information. This is kind of similar, except these don't have to be nice little columns, right? You can have them as different things, but you can just access the same stuff with robot1.x and robot1.y. So it keeps it together a bit nicer.
So the only difference from object language is that it's not going to ask you to write it down, but if you run it for an object, then it works the same.
Yeah, so the difference more explicitly, and we're talking about classes at this point.
Yeah.
A class is a structure on steroids that has more capabilities. So you can inherit a class, right? If you make a human class that everyone has a name, a weight, and a height, right? And you can make a subclass from that gets all these values. We call it a child, you know, a baby human, right? And then the baby human has all the properties of the adult human plus some other things that you would add onto it. We're not going to get more into that for now. That's going to blow some people's minds. Still blows my mind. But C++ uses classes all the time. A good C++ code will be only using classes all over the place and passing information, but it's also passing everything by reference instead of by value. That's a whole other world.
But this can do a lot of as well.
But yeah, but for what we're trying to do, you don't need that, right? This is what you're talking about, using the tool for the right activity. You don't need to learn C++ to do what we're trying to do in this class. What you're trying to do for your research, right? Depending on how crazy your research is. But it's knowing when to use those things. My research is in C++ because we're doing an extremely computationally intensive computation. So we have to use C++, and we can't be passing things around willy-nilly because we're dealing with those million by million data sets of things that we're trying to process live, online on a vehicle somewhere. MATLAB can't do that. Python can't even do that. We have to use C++. It's the fastest language, and we can take advantage of those things. Otherwise, you don't need to do that. Right? Okay. How'd that go? You guys feeling okay? It's tough.
Really nice class.
Yeah, I'm glad. I hope you guys get some stuff out of it. Shout out to the online viewers. I'm not sure if people tuned in or not. We're still live streaming. I gotta check the chat. Oh yeah, I didn't tell you that, Fiona. We were live streaming this today.
There were people online, definitely.
On YouTube. Some people are saying hello. Let's see if there's any questions. But yeah, we were live streaming. My first time ever live streaming to YouTube. Kind of fun. Yeah, so I'll end with, again guys, if you're really concerned about topics, you want to review stuff, my channel can help you out a little bit. Go into the playlists, or just go right down here in the playlist. This is the best video. It basically covers all the stuff we covered today.
This was you.
Yeah.
Makes total sense.
Yep. So, and it's a little bit more organized because I'm not doing it live, but it goes through all these different topics. You can jump to different things you want. Otherwise, you know, all the basics, things you're doing, conditional statements, making your own functions. If you're doing Python, I got videos on that too. More advanced stuff, taking integrals. This is the one you should watch, how to load, clean, and visualize raw CSV data. That's going to be your winner video there. You can make videos in MATLAB of stuff, like a cosine, like a moving cosine thing. Probability simulations. I was doing this a bunch with some dice roll stuff, one of my random process classes here. Fourier transforms, gradient descent, things like that. Whole image processing series here. So if you're doing like converting between different grayscale images, color scales, thresholding, changing titles on your images. Actually, I have a plotting series that I don't think is, I haven't made that available yet. Here, MATLAB plots and graphs. So Mike, this is going to be where I'd recommend you start. Go anywhere you want, but
Well, it's like silly things with plots, right? So So one of them was I created my plots for this presentation, and the header or the title was right up against the edge of the plot. So like just
Like
you
just
know,
the basic formatting stuff.
like an hour of videos trying to everybody's little hack on how to move it, and sometimes he rearranges everything so the plot is meaningless. You're like, oh my god. And Nicole, one of my friends, came over and she was like, here, try this piece, and it worked fine. I was like, great. I don't even care what the mystery is.
Oh my
It looks
god,
good.
it looks good. Yeah, no, it's painful. Formatting is. MATLAB has a lot of good stuff. Like with the GUI, I think one of my videos goes over the figure window, because that's how you can actually customize stuff really nicely in the GUI instead of trying to find a command for it. Let me see if I have the video on that. How to use the figure. That might be in something else I've done. Might be in one of those videos. But you can like literally click and drag the things in a plot using that plot figure. But yeah, so fancy types of plots, adding text to plots, histograms, bar plots, pie charts, all in there as well. So if you guys want any of that stuff, have at it. Go home, get some rest. I'll stay around if you guys have any questions, but otherwise, enjoy the day.
It's really nice. Cool.
Thank you for coming. Yeah. So I got thrown into the deep end here, Fiona.
Oh,
After the intro, but you seem to do pretty well. You're doing alright.
It was a good review.
Okay. Good.
Is Alexa already gone on scene?
Yeah, she's been out there for about a month now.
What? For a month?
Well, no, sorry, a couple weeks. I think it's been 1 week actually.
Yeah, like
Not a month.
I saw her like
I was
Monday.
gonna say, like, wait, I've been in school for a month.
Yeah.
Yeah, I think she left, I
Oh.
don't know what day. But she, apparently, if there's like a hurricane that might be coming through, might be coming back from their cruise early. We'll see. We shall see.
Like the German the German girls living in one of the shores.
Yeah.
They talked to her about her surfboard because she's not.
Yes.
Use it. Like, are you guys living together? Actually.
No, we are not.
But like she said, like we could pick up her board at your place. Is it at your place?
I could get her board if you need it. Yeah. I know where she lives.
That's helpful. Cool. Yeah, but like if we
take
could,
care. Thanks for coming. Nice mug.
if we could manage sometime to pick it up.
Yeah, sure. Is someone buying it from her?
No, it's
Or-
just like she's actually
You think
like
maybe-
she's actually it's really sweet. She's just like they are just borrowing it.
Okay. See you,
Yeah.
Fiona.
I guess like
Thank you for teaching.
I guess she should get a.
Super useful.
Good to hear. Thanks, River.
I guess she's gonna get like a dinner invitation.
Ooh.
Hopefully.
Okay.
Like I hope that because like the board I think should also be perfect. It's like 7.6 for me. Are you surfing?
I do occasionally surf. It's not the greatest, but I will go out and try to catch some waves here and there.
Because you look quite athletic. So
Oh, thank you.
like you could do some surfing.
Yeah.
Yeah. 'Cause
Felix and Aylin they were surfing so much.
Yeah.
It's crazy.
Yeah, I'm gonna surf so much. Like not
Okay.
maybe not as much as Felix, but like I'm gonna try to surf. Yeah.
Good.
So,
Good. Yeah, they were there like, all the time. It was super fun to have them around. They were good.